大家下午好。
Good afternoon, everyone.
好，我接下来就正式开始
So,
今天
without
下午的这
further
个会
ado,
议程。
let us
因为
start
这个会议
the
因为项目
session
今天，然后今天又有
for
3个
this
Recording in
forum.
progress.
可能每个
As you
分会
know,
呢，有一些
our
嘉宾是刚刚参加，所以我就再
Clean
花一些时间来
Asia
介绍
Clean
一下
Air
我们这个会议
Exchange
的
lasts
这个
for
背景
3 days,
过去
and
2
we
天的
have
这个参
3
会的情
separate
况。那
sessions
这
for
个
this
活动呢
afternoon.
是由亚洲
So
工业
allow
厂
me
发
to
起
give
和
you
支持
a
的
brief
一个亚
introduction.
洲区域性进口合
This
作项目，其中一项重
is
要
a
的内容
regional
就是经济中
roundtable
国在
supported
空
by
气污染治理
ADB.
方面，在国家层
One
面、
of the
城市
important
层面、
parts
行业层
is
面、
to
企业
share
层
the
面
China
4个不同
experience
的方面的
from
这里
the
的经验和技
national,
术传输给中国，
municipal,
包括蒙古、越南、菲律
industrial,
宾、孟加拉
and
和巴基斯坦这几个
enterprise
参加
level
直接参加
to
技术的
other
国家。
participating
同时，我们
countries
同
like
时会将
Mongolia,
所有的这个项目的
Vietnam,
产出，包括
and
会
other
议的这
countries.
个
And for all
在这个
the
会议的这个内
output
容、讲
of
座以及
this
这个线
program,
下行程的课程、
including
技术
our
手册、
presentation
培训手册
for
和
this
企业的技
exchange
术资料，
and various
在
training materials, technical
在网站上
documents
传和一
will
些
be
学习和
uploaded
知识平
to
台等
our
的
website
项目产
as
出
well
平
as
台，
other
持
knowledge
续分享
platforms.
扩大这个项目产
So
出的
there
影
will
响。
be
在过
continuous
去2
sharing
天，
to
我们
optimize the impact of
通
the
过这个会议
product
本身
delivery.
吸纳了
For
会
the
议
past
平台
2
的这
days,
个观看
we
人次
have
是观看人数累
received
计是300 人，
more
然
than
后也有很多人
300
是通过
viewers
直播，
via
除了这个课
virtual
和会议网站平台之外，来关注我们这个
meeting
会
room,
议活动。
and many other
观看人
join
数
us
累计应该是近1
via
万。
live
在
broadcasting,
过去2天呢，
and the
我们
viewer
会
on live broadcasting
有比较
platform
引发比较
exceeds
大的这个关注，在中国的日报
50,000.
啊，像北京
We
日报、
received
还
great
新华
attention.
这
There
些
is
主流的
media report
杂
from
志
China
和媒体
Environment
上都
News,
进行了报
Beijing
道。
Daily, as
在
well
今
as
天的会议
Caixin
场， 我们
Magazine.
是
And
分
today
为
is
不同
the
的主
last
题。
day.
这
We
是今
have
天分
several
会场，我们会
specific
聚焦在垃
themes.
圾处理和
We
净
are
氧这
on
2个具
session
体的这
3 on
个行业
urban
上。
waste
非常
management
荣幸
and
邀请
break
到的行
king.
业专家，
We are
一
very
些
honored
这
to
个
have
行业专家
expert
推
with
荐的一
us
些优秀
who
的
will
企业，
share
来
with us
参
their
加作为这个
experience.
提供
The
技术解
expert
决方案
also
的
recommended
方代表。那希望呢，
selective
我们这个会
suppliers
议交流平台
who
和
are
本场会议
excellent
记录
in
的
that
这个
arena.
系列产出，
So I
能
do
够
hope
成为中
that
国和
via
各
this
家新兴合
exchange,
作的桥
as
梁。
well as
那
this
我们这
product,
个开场
we
白
can
就先
build
到这
a
里。
bridge
我呢，
of
应该介
China
绍
and
先
other
介绍一
Asian
个背景，
countries
就是作为这个
for
事业项
technology
目， 我们有
exchanges.
有一
So
个
I
相
just
应的
share
这
with
个
you this background
记录和
and
参考。那
introduction.
这个活动本
We
身
would
是为
also
了
have a
帮
record
助到大家，并且邀请大家参与
to
这个技
gather
术
your
研讨的这
feedback
些活
on
动，来做一个就是
your opinion
反馈。
on
所以
our
我请到了这
technology
个总部的这个同
virtual
事来做
exchange.
一个会前小测试。
So our
需要大
headquarters
家可能花个
colleagues
1-2分钟
would
时
like to
间。
have
好，非常感
a
谢。
questionnaire for you that will take you for around 1 minute or 2.
Hi, Dan. I think we can do the pre-test. Thank you.
Thank you, Wei. So I will be launching 10 a questionnaire, 6 questions, requesting our participants in the room to please answer the 6 questions, basically baselining the knowledge of the participants or the familiarity with the topics that will be covered. And we will definitely use this to assess the impact of this particular session. So you would notice that so since this particular session is focused on air quality management practices in the urban setting, as well as brick kilns, so we would like everyone to please to please answer our questions. So can I I will relaunch the poll.
Yeah, the poll disappears.
Okay, so requesting
Yeah.
the other co-hosts in the room to not someone ended it again. Let me relaunch it again. So requesting the co-hosts in the room to not end the poll.
请大家不要点结束问卷，由我的同事当来点结束问卷，否则的话就会被中断。
Thank you. All right, so I can see now some responses. So I encourage everyone to please participate in the poll. Okay. So there, thank you. I can see some responses. Maybe we can have a couple of minutes more to allow the around 30 participants in the room to participate. So thank you. We see now 8 responses, 9 responses, 11. Thank you. Okay, 1 minute more. So I see around 36 people in the room. And I see our colleagues from Mongolia, from the Philippines as well. And of course also from Bangladesh and Vietnam. All right, last 20 seconds. All right, I think that's sufficient. Thank you, Wei. I will now end the call and hand it over back to you.
Thank you. So I transfer back to Chinese to introduce our speakers for this afternoon. 好的，那我们就进入
All right, thank you. Now we move over to the presentation part. Let me give you a brief introduction of the agenda. We will have technology training presentations by sector experts with the theme of urban waste management as well as brick kiln. So these technologies, introductions, what are the suitable environment, what is the cost, down investment and its returns, and the tips while you're applying these technologies. So that is the first part. And part 2 of this session will be technology introduction by selected suppliers, the top enterprises in China in their specific industries to give us introduction. We do have a pretty long schedule. We will have the break and Q&A session between the closing ceremony and our session 3. So it is recommended that we can adjust the agenda that after our 2 sector experts finish their presentation, namely Mr. Liu Zhe and Sanu Babu Dango, we will give you a very brief, short 5 minutes break. And if you do have very urgent questions, you're also welcome to raise your question during that break. And then we move over to technology introduction by the selected suppliers. So we have taken some time for the opening and the questionnaire. So these speakers, please do your presentation according to your plan, as we do not have as many speakers as the other sessions, so take your time. So I'd like to give the floor to Liu Zhe, Secretary General of Technical Committee on Waste to Energy Standardization of China Electricity Council. So please share your screen, Mr. Liu, and start your presentation. Okay, can you see me well? Yes. Please start. Thank you, moderator. I'd like to congratulate the convening of this China Clean Air Exchange. It's a great success. I'm honored to be part of the project and to see it have a profound influence. For distinguished guests home and abroad, dear friends, good afternoon. Yesterday, I shared with you the relevant policies for China's urban waste management and some cases for certain cities. So today, let me give you an introduction on the technologies adopted in China for urban waste management. I'd also like to share with you some of the cases as well as the several applications of these technologies. So today I would like to cover these three parts. So allow me to explain, because different from the other industries, waste treatment itself is a measure of the pollutant control and emission reduction. Yet during the process of waste treatment, there might be further pollutant generated. So they'll give you further challenge of controlling the pollutant emissions. So I'll cover the following three parts. Overview of urban domestic waste treatment in China, typical technologies and processes of domestic waste treatment, and typical technology and processes of pollution control for domestic waste treatment. Because I do have many to cover, so I would not give you great details for each of these technologies because we have high quality enterprises from this sector who will give you an introduction of greater details. So first of all, let me review some of the figures given yesterday. In 2020, the annual harmless treatment capacity or urban domestic treatment in China was 234 million tons, in which capacity of incineration was 146 million tons, accounting for 60%. There are 463 waste incineration facilities in operation and nearly 100 under construction. There are three main methods of domestic waste treatment: landfill, incineration, and composting. So the blue bars are for landfill, the orange bars for incineration, composting, and others are the gray bars. As you can see, along the constant optimization and adjustment of waste treatment structure in China, there's also change in the breakdown. So incineration gradually becomes the mainstream, which exceeds that of landfill in 2019, and in 2020 it accounted for 62%. So let's move over to another perspective, that is waste to energy. In 2020, the installed capacity had reached 15.33 million kilowatts. The annual on-grid electricity quantity exceeds 50 billion kilowatt hour. And now let me give you an overview for the urban domestic waste treatment in China. You can see this is a table to compare the similarities and differences. I listed 4 here, including incineration, sanitary landfill, and composting. And yesterday we'll also talk about, after we have the various categorization for the waste. For kitchen waste, we also have anaerobic fermentation technology, and we're building these facilities. That is why I listed these 4 methods here on my slides. First of all, let's look at its applicability. Both incineration and landfill are applicable for general domestic waste. As for aerobic composting and anaerobic fermentation, they have a certain requirement for the organic part in the waste. And you can see they're good for kitchen waste, particularly for fermentation. Let's look at the land area. Incineration usually takes 30 to 180,000 square meters. For landfill, they will need a much larger area, from 50 to 400,000 square meters. It is the one that requires the largest area. And for the aerobic composting, take a capacity of 500 tons per day. That will need 50 to 120,000 square meters. And for the same capacity, anaerobic fermentation only 25 to 30 square meters.
So based on the daily treatment, how many tons can we treat per day? So for incineration, your investment cost ranges from 0.25 to 1 million per ton, while that of landfill ranges from 0.1 to 0.3 million RMB per ton, while aerobic composting is 0.3 to 0.5 million per ton, and that of the anaerobic fermentation is from 0.4 to 1 million RMB per ton. So they are all below 1 million tons, while for OPEX, the cost differs wildly from each other and based on the same criteria. That for incineration is from 70 to 150 RMB per ton. That of landfill is 60 to 90 RMB per ton, while composting is more than 150 RMB per ton, while fermentation is ranging from RMB 100 to 500 per ton. Okay, so let's move on to the effectiveness of treatment. So the measurement on the effectiveness of treatment is a low degree of like reduction or high degree of reduction or that of recycling. So the first is the reduction. It can realize harmlessness. It can realize harmlessness. So we focus on the reduction and the recycling. Number one, for incineration, it has very high degree of reduction. It can reduce the volume by 90% and also 75% by weight. It has high degree of recycling. Electricity, heat can be utilized. Yeah, for landfill, it has relatively lower degree of both reduction and recycling. And also for the aerobic composting, it has moderate degree of reduction. So apart from also the fertilizer, still that will be a 20 to 25%, which needs to be further treated. Well, in terms of the recycling, it can be used as the fertilizer. Yeah, the application of this fertilizer maybe some challenges. And also when it comes to the fermentation, it has very high degree of reduction, reduced by 80%, while that of recycling is very high. You have electricity, CNG, biomass, or the biodiesel. Yeah. And the next is that from the so-called secondary pollution. So these are the comparison we have. Yeah, also again, for incineration, it may also generate the heavy metals, the flue gas, and ash, which requires further treatment, especially for flue gas treatment is very demanding. And for heavy metals, as we mentioned, it is very high on the radar of regulation. And also for landfill, in terms of one of the secondary pollution is the odor, a very serious odor. Yeah, in terms of the large area of impermeable membrane needed, it's very important. If it cannot be treated very well, it will pose threats to both underground water and the soil. And the third one is for the composting. Yeah, and the odor pollution may be one big challenge. And there will be some possible pollution by heavy metals in fertilizers. It will have some negative impact on the sales of fertilizer. Next is about anaerobic fermentation. It has non-biodegradable residues, requires incineration disposal. Yeah, for these four different challenges or problems, we have just listed them here as an overview. For incineration, you can see that it still need to improve its technical standards, and it's about governance regulation. While for landfill, one of the key challenge is more about a serious occupation of the land resources. And also again, for composting, and you need to guarantee of the market sales and of the fertilizer cannot be very well guaranteed. And again, for aerobic ones, in terms of how we may address the residues, difficult final residual disposal. Yep, these are the key characteristics of these four different ways of treatment. I'm gonna move more specifically on each of them in terms of the technologies and the processes of domestic waste treatment. Yeah, number one is from also the waste incineration. So this is also the whole process schematic overview of the process I'm introduce you. So starting from very quickly, we collect the waste, transport the waste by the vehicles to the unloading platform. That's number one of this chart, where also the waste will be unloaded to position number two. That's the waste bunker at the waste bunker, it will last for 5 to 7 days. For fermentation and filter the water, increase the heat value. Number 3 is the waste crane control room, where you have the operators to control the waste crane, which is number 4, and to really catch them and put them into hopper, number 5. And then we may use feeding platform, which is number 6. It will enter incinerator for incineration, that's number 8. The following processes are very similar compared to coal firing. All of these ash will enter number 10, heat recovery boiler for heat exchange. And the water will be converted into especially the gas at middle temperature, and also relatively speaking at the middle pressure. It will enter number 18 and 18 steam turbine in the generator unit for power generation. It can be used internally or it can be connected to the grid. The above mentioned are about the process, about receive that and for power generation. So we have 1 in, 4 out. 1 in is about waste. 4 out means there are 4 pollutants, including the different gas and the fly ash and residues, the slag that must be treated as also shown here. Okay, number 1, in terms of the ash treatment, soot and ash. It has actually quite multiple steps, very complicated in terms of the flue gas treatment. Let's take one example. So for flue gas, you have active carbon to remove also the heavy metal, and also you have the deacidification, remove the acid, the acidification. And number 13 is the line motor system. Number 14, then back filter system. Then from number 15, induced draught fan. It will enter the chimney. Number 16, stack chimney. So these flue gas, which is compliant with the regulation, will be emitted. For the others, we have also we have residues, especially in the leachate. It is of very high concentration about the leachate. You need to be must be addressed, treated. Next is about residues. So we can see that there's a dedicated chamber for the furnace cinder, furnace slag. It will enter the slag chamber, and this needs to be further treated, the slag bunker. And also for flash ash, there's a ash bin for collection, and also it can be used as hazardous residues for reuse. We can use the solidification as the treatment. The above mentioned are the introduction of the processes we have. Now we are going to move to key equipments of the incineration, covering the system, the air distributor, the furnace separator, external heat exchanger, cooling chamber, low temperature superheater, the air preheater, and also includes the vent gas treatment and water feeding system, deslagging system, etc. Okay, what we want to focus on a lot is about the furnace. So there are 2 different schools of technology. The first is grate furnace, the other is the FVP, fluidized bed. What are the difference of the 2? So from the process per se, the first one, grate furnace, it has been adopting the movement of the grates, that the waste is pushed downward through this movement of the grates. It passes through each area on the grates in succession and until it is incinerated and discharged from the furnace. FVP has been adopted for years. So a large amount of coiled sand is added into the furnace, and hot air is blown in under the furnace to make the hot sand boiling. Then the water is fed into the boil and burned with the hot sand. The advantage of the GFP is the technology is sophisticated with little amount of fly ash, stable deslagging system, and a simple control on combustion. Well, the drawbacks is that it is more costly compared to that of FBP, high maintenance cost, big volume. But now, with the localization of this equipment, the price of the GFP started to drop. Well, for FBP, the advantage is that it is more affordable, less investment. It has more thorough combustion, very high efficiency of thermal efficiency. But disadvantage is that you need a pre-treatment, and also it is really the coal required in need of coal required coal doping has high operating cost and a large amount of fly ash, and the mainstreamer remains the greater furnace process GFP, the absolute mainstreamer. Yeah, in the big, small-sized or medium-sized city, basically speaking, we used also the GBP, the equipments are also being more and more localized. And let's take Shanghai, the tier 1 city, as example. There are 16 projects of incineration. All of them are based on the GFP, the Great Furnace Process, 9 of which are imported. 7 out of 16 are the domestically produced products. Okay, let's move on to the investment cost and subsidies. Yeah, in terms of the cost factors on investment about waste incineration are quite diversified, including the size of the investment, the land cost, the equipment, as well as the head counts, the human resources or labor cost. For GFP, the investment cost per unit ranges from 0.3 to 1 million, while that of FBP is lower, 0.25 RMB to 0.3 RMB per ton. But as we mentioned, example in Shanghai, the average investment of 16 projects is around 0.68 million RMB per ton. The operating cost includes the auxiliary, the materials and maintenance, O&M, including human resources, labor, land cost. So we mentioned it already ranges from like 70 to even 150, but in Shanghai it's 50 to 90. The main source of income for incineration, it comes from the subsidy, as we mentioned. The other is also the tariff. Yeah, the first is about the waste treatment subsidy. It's closely related to the cost of incineration equipment adopted, as well as its boundary conditions. It varies quite a lot from project to project. Generally speaking, the subsidy may range from 30 RMB to even 200 RMB per ton. From actually the tariff, on-grid tariff, the subsidy of the tariff accounts for even 60 to 75% of the total income of the incineration project. Yesterday, we even mentioned about a policy issued in 2012, a notice on improving the pricing policy for waste incineration power generation. It determines the waste to energy project using domestic waste as raw material. So you need to remember the price was tentatively set at 280 kWp. The national unified benchmark is also 0.65 kWh, not kWp. In 2020, the subsidy policy was changed and clearly specified the condition for so-called subsidy cutoff. So the utilization across the life cycle reasonable time is 82,500 hours or 15 years. So the one which can be reached first will be adopted. Okay, the above mentioned is more about our overview on incineration. Now we need to move on to landfill. Okay, when it comes to the landfill, it is relatively simple. Yeah, it is more about to build the landfill area. We're talking about the membrane, to build a membrane, as well as the collection of the leachate. Yeah, the waste truck enter. We will check the waste characteristics. It will be weighted and measured and dumping on the work surface, and also move on to spraying the insecticides to kill the insect eggs, and also disinfection, etc. You will also have hierarchical landfill. You need to flattening and compacting each layer, the earth covering, the vegetation covering. That will generate some other pollutants. We mentioned about the leachate. Leachate is very important. It is of big volume. You must address that. You need a dedicated collection, and there's a leachate treatment station. Yeah, when you reach the compliance, it will be emitted to a sewage pipe network. And next, it will also generate a lot of gas. And we need to collect the landfill gas, some of which were used to torch. LFG used to torch for ignite it, and some of this LFG will be used for the generation. Okay, From the project per se, it covers the area of the landfill. It covers the site view, a waste dam, the leachate diversion system, treatment system, the gas drainage tree system, the closure engineering. It accounts for 70 to 90% of the total area.
So you can see the major system includes all of the things like this compactor, bulldozer, loader, as well as the other major equipment. And the leakage I just introduced, it is one of the major pollutant in landfill, and the seepage may cause great damage. Right now, we're using the HDPE seepage control technology. And now let's move to the third part, that is composting. First of all, what is composting? It is a technology utilizes microbes, so degrade or digest the organic matters into waste and therefore form a kind of substance similar to humus soil, which can be used as a fertilizer. There are two ways: anaerobic composting and aerobic composting, with different kind of bacteria or microbes used, for which you can see the aerobic composting have been widely used due to short period, high degree of harmless treatment, and good sanitary condition. And now let me show you several different common systems for anaerobic composting: static aerated pile, troll bank type, as well as drum type. It is relatively easy. You can see we first would like to crush them and have a secondary fermentation. Prior to that, we will adjust the carbon-nitrogen ratio and then add a certain phosphorus element, and then it can be stored or transported. And then let's move over to the anaerobic fermentation, also known as anaerobic digestion or biogas fermentation. It is a process we have organic matters that catalyzed by various microbes, and we can form combustible mixed gas as methane, as well as the biogas slurry and residues. In recent years, with the advancement of waste classification, this has been extensively used in kitchen waste treatment. So here is a comparison of various ways of treating kitchen waste, including the anaerobic fermentation, as well as the feed conversion. So the major two parts are for anaerobic fermentation and aerobic composting, as feed conversion are rarely used. So you can see for the degree of harmless treatment, fermentation outplay that of composting. For recycling, it is also high. For the land area, relatively similar. For investment per unit, you can see that the fermentation is higher than that of composting. Operation costs are similar. So if you check the difficulty of this technology, its major lies in the treatment, including the feeding conveyor, the sorting, impurity removing, solid liquid separation, and crushing. And on the slide, you can see a diagram showcasing crushing, sorting, and pressing pumping process. And then for the anaerobic fermentation, it is a common procedure. So we would like to control the temperature as well as the flow reflux ratio and add additional carbon resource. So that was the very brief introduction of the four major technologies and processes of domestic waste treatment. And now let me move over to the pollutant control for domestic waste treatment. Here are the typical technologies and processes. As you know, the most harmful secondary pollutants are flue gas of waste incineration, as well as the leachate of landfill and the fly ash. So if you first check the flue gas, here are relevant pollutants, including the particulate matters, acid gases, organic chlorides, and heavy metals. These acidic gases are highly corrosive, And you know that the organic chloride, like dioxins, they're kind of highly toxic chemicals, and heavy metal element also directly harm human health. So you must purify this flue gas before you discharge it in the atmosphere. As you can see, we have two parts, including the dust removal and the absorption purification. We have various process like SCR denitrification, desulfication, as well as the activated carbon absorption, etc. So all of these are aimed to control this pollutant, and we can discharge while complying to all the standards. So I think this is a common concern for the public, dioxin. It is one of our key targets of policy measures. Yesterday, we talked about this standard several times. Standard for pollution control on the municipal solid waste incineration. You can see there is a very specific requirement of dioxin, and you can also see they have a particular requirement for the process that the incineration temperature should be higher than 850 degrees C, and the flue gas need to stay more than 1 second. And that is the effective method to remove all the dioxin in the flue gas. So yesterday we also mentioned this part that are the emission standard for different countries. You can see China is among the most stringent of all, 0.1. And if you look at the technologies, let's take SNCR, denitrification plus semi-dry plus dry process plus activated carbon and the back filter. So you can see this is just example, and later we have all these suppliers who will give us a more greater detail introduction of that. Other than the flue gas, you can see we have the leachate as the other pollutant. So for the leachate, you can see it will be generated for both incineration, landfill, as well as composting. It is also a complex pollutant with high concentration. Its a major issue is for the concentrated solution. Fly ash major comes from incinerators. It's also quite pollutant. They have heavy metals as well as dioxin. The mainstream technology is solidification or stabilization, as well as cement kiln core processing. So here I would like to give you a brief example of the leachate treatment process. And you can see this major technology include regulating reservoir pretreatment, anaerobic plus biochemical NBR plus advanced treatment. For the difficult part, we will have this anti-seepage as well as the NVR and others. So this will help us to do a simplified and comprehensive treatment. And for the details, I do believe the following suppliers will give you more greater details. Flue gas, let me show you this new technology called Rotary kiln cistern melting technology. We use the rotary kiln to have high temperature firing, so it can harmless treatment and can have recycling for fly ash and contaminated soil. So that was my part on all these technologies of urban waste management. I covered many different technologies and processes, and due to limit of time, I was quite brief and concise. The details can be shared by the later suppliers. So the four of them are leaders in the industry for urban waste management, and they will share with us their respective perspective of flue gas, leachate, incineration, as well as fermentation. And we have Shanghai SUS Environment and China Everbright. They're leaders in incineration, and they have invested and operated various facilities of incineration, and they have their own equipment and technologies with great international market. As for Jiangsu Huaxin, this is a leading supplier for flue gas treatment for incineration, also taking a certain share on the international market. Beijing G Grain comes from the areas of kitchen waste disposal as well as leachate treatment. So let us have great expectation for their later sharing. That is all from me. Thank you very much. Back to you, moderator. Okay, thank you very much, Mr. Liu Zhe. That was a great representation. And according to our schedule, we will have our next speaker, who is an expert for zebra kilns. We have Sanu Babu Dango from Nepal. He's a representative of Manergy. So he seems to have some connection issues. Let's try again with Sanu. If that's not possible for now, we can move to the next speaker.
Can you try to open your audio and micro? Hello. Okay.
Hello. Hello, namaste.
Would you please try to share your screen and slides?
Sure. Yeah.
Okay. Please use full screen.
Is it?
Thanks. Yes.
Can you see my slide now?
Clearly.
Okay. Is it okay? Shall I start now?
Please go ahead. It's
okay. Namaste to all. I am Sanu Babu Dangul. My name is Sanu Babu Dangul, and I'm a civil engineer by profession. I'm working as a brick expert since very long. My actually career started with the civil engineering, but when I joined BSBK brick project, BSBK project in Nepal in 2007, that is energy efficient brick technology. So my career on bricks started from 2007. And from that time, I'm still on the brick sector, working on different aspect of brick project energy efficiency and operation, as well as construction of the energy efficient brick kilns. So that's how I started my brick career. So I'm now working in Minergy Private Limited, which from the beginning, which started in 2008. So this is my brief introduction. So shall I go to the slides now? Okay. So I will start my first place today. So this is the type of kilns which we found in especially in Nepal, as well as especially in the South in Asian countries. So if you see this slide here, we have the
hi, Sanu. I think we
fish chimney bull trans kiln, and another is FCBTK zigzag. That is FCBTK zigzag, then BSBK, and we have another very sophisticated and very expensive kiln also, tunnel kiln, hybrid Hoffman kiln, and Hoffman kilns are still in operation. But if you see here in the technology, especially in Nepal, and I think it's the same in other countries of South Asia. So if you see here, FCBTK is the most prevalent technology here, and FCBTK, then FCBTK zigzag. You can, if you see, it's the name is same, FCBTK and FCBTK zigzag. So it seems that it's a more similar technology, but it's quite different in aspect of operation and in structure. So these are the most prevalent technologies in Nepal. If you see in the proportion, so it's around more than 80% of the kilns are FCBTK now. So another is the zigzag, FCBTK zigzag. It's about 10 to 12%, 10 to 15%. So another rest are the another kilns like BSBK tunnel kilns, hybrid Hoffman kiln, clamp kilns, like that. So today my presentation is more focused on FCBTK and zigzag. What are the improvement that we did in FCBTK zigzag? So if we go to the slide, then in the context of Nepal, we see the mainstream technology are FCBTK and zigzag. So what are the difference? What are the difference between FCBTK and zigzag? So we can see the basic difference as a visitor or as a as a person who goes to the kiln. He see the salient difference is the structure of the kiln of FCBTK and zigzag. So you see the kiln, the ends of the kiln in FCBTK is a full fixed chimney bull trench kiln. It's the oval shape. The ends are oval shape. Whereas in FCBTK zigzag, you can see the ends of the kiln are square. So there are the basic difference which we can observe from outside. This is the one. The another difference is the stacking pattern. You see in straight line, you see the FCBTK straight line. We say it's straight line and zigzag. The straight line is nothing but the stacking pattern of the green bricks. If you see in the slide in the left side, that's FCBTK. That is the stacking pattern is very straight line. So the fire moves in a straight part. Whereas in FCBTK, the straight line is covered with the wall. That means when the fire moves in the straight line, when the wall comes in between, then the fire is diverted in zigzag part. So that's why we say it zigzag kiln. You can see clearly here is the fire movement. In the left side, it's FCBTK, which is a straight line. You see the fire movement is very straight. So there is the part of the fire is straight, whereas in another part there are lots of walls that we can say it's a baffle wall created and in the stacking pattern itself, in the green brick itself, so that the fire movement, when fire flows, it will collide with the wall and it takes the zigzag pattern of the fire. So that's why we call it. So you can see that the length of the fire is quite less in FCBTK straight line, whereas in zigzag the length of the same fire becomes longer because of the created the zigzag pattern. That is the salient difference of FCBTK and zigzag kiln. So another is the firing zone. In the operation also we can see in zigzag in straight line we have 2 or 3 fire feed holes only. Whereas in zigzag kiln, we have at least 10 fire lines, feed holes lines, more than 10, 12, 14. We can see at least 10 firing lines in the zigzag kiln. Whereas in the FCBTK, it's 2 or 3. The another difference is the firing practice is in the FCBTK, we have in FCBTK, the feeding is intermittent. That means one fireman keep on feeding for nearly 10-15 minutes, and then he take a rest for 30 minutes like that. But in FCBTK, it's a continuous feeding. One person keeps on feeding for a continuous process. In FCBTK, it's a double man. Double or even 3 man keeps on feeding for one time and take rest for half an hour. Whereas in FCBTK zigzag, one single person keep on feeding for a continuous process. Whereas in FCBTK, they use big spoons to feed, so that they accumulate lots of coal or fuel in the feed holes. Whereas in FCBTK zigzag, they have the small feeding spoons. So small quantity of the calculated small quantity of fuel in a calculated way in continuous feeding. So they follow this pattern in zigzag, which makes a more efficient fuel efficiency and environmental friendly in zigzag kilns. So if you see the differences, then what are the similarities in FCBTK and zigzag? The similarities we can observe that except the kiln structures, all the working practices are similar with in both the kilns. Green brick making process are the same. Operation practice almost are same. The kiln structure are almost same except the corners of the kiln. The same structure for the FCBTK can use for zigzag with small improvements in the kiln itself. So that is the main reason that when we FCBTK are converted in a new technology, then the tendency of rather than in the expensive kilns like tunnel kiln or hybrid Hoffman kiln, because they spare they have to spend a little amount of money for improvement or conversion, whereas to completely new technology they have to invest heavy investment. So another context went in Nepal is we had a huge earthquake, as you all huge earthquake in 2015. So then we can see the damage at that time.
Recording in progress.
Time we had nearly about 900 to 1,000 brick kilns only, and where 350 kilns damaged because of that big earthquake. And we have 108 kilns in Kathmandu Valley. Out of 108, 105 kilns were damaged. And the estimated loss at the time was 1.12 billion of Nepali rupees, and where production loss was about more than 40% due to this earthquake. So, which triggered to develop a design manual with the help of different funding agencies like CHURN and the ICIMOD. They come up with the funding for the zigzag kilns. So what we decided is to have a kind of right design, which is earthquake resistant, which is energy efficient and lower emitting for the new building of the kiln itself. So we just started working with the team of engineers and brick entrepreneurs and the practitioners, so that we can collect all the information, all the data to improve the zigzag kiln itself, to improve the fixed chimney into zigzag. So what are the improvements that we did? We can see these are the improvements that we can see. We designed new kiln chimney. We designed for outer wall. We calculated for the heat loss from the wall, outer wall wicket gate. That is the gate which is used to take in or out the grain bricks and fire brick. So we also designed the flue duct, the size of the ducts, inlets and outlet. Everything we designed in proper way. So these are some pictures of the improvement that we did. The salient improvement is in chimney. The chimney is newly built, newly designed, because beforehand it was the big, huge chimneys for the FCBTK. It was about 110 feet or 130 feet, above 100 feet. It was huge and bulky, which does not have any lateral structural element to withstand the lateral load due to the earthquake. So what we did is we did RC, reinforced concrete frames chimney, or the metal chimney. We just replaced all the chimney with the RC, or we give the two options, so that even if there is another earthquake, the damage due to the chimney will be less. We give three options. One is RC, completely reinforced concrete chimney, or the iron frame chimney, or for the someone who's natural draft, they need very longer chimney, more than 100 feet. They can also go for that one, but with the RC design, with the earthquake resistant design. So this is a salient change in the design improvement that we did during the improvement. And another change is in the wall itself. Initially, it was very slim wall structure, about 18 inches or 2 feet, or very slim structure of outer wall. But we changed in new design with a very heavy and bulky wall with the cavity inside. It considered a seismic consideration, the lateral load, the air leakage control, heat loss control. It control the heat loss. It controls the leakage from the inside or outside, and it is also earthquake safe. So this that is another big change that we did in the improved kiln. The another changes are the proper sizing and spacing of the inlets, that we can say the flue inlet and outlet, and also use the concrete pipe inside the concrete hume pipe we say here in Nepal. We use the concrete pipe in the inlet outlet of the kiln itself, which is very energy efficient, which is very faster to construct, which is very easy to maintain. So that we did the proper calculation of the flow of the flue gas, the quantity of the flue, then the velocity of the flue gas, so that we design the main appropriate sizing of the flue, the inlet of the pipes. So that is another one, and this is another change that we did in the kiln floor. That is the floor which has initially they has only very thin kind of flooring system, which has a huge amount of losses from the floor. So what we did is we put about 1 foot thick sand on the floor, and with the aluminium foil at the center of the sand. And we additional we just put this brick layer of soling with a flat brick and brick on flat and brick on top, brick on edge. So that's how the thickness of the thickness of the soling is quite high, which imparts in losing of the heat loss from the ground. That is another change that we did in improved kiln. Another design that we made is in the fan system. Initially, it was the natural draft. Then when we went to the induced draft or a forced draft, then we designed a proper mechanically engineered design for the fan system, calculating all the required quantity of flue to be passed through the chimney. So we also introduced the VFD. It's a very variable frequency drive system in the fan, so that if we need the higher amount of RPM, we can increase the RPM as per RPM means the revolution per minute as per our need. So that is another change that we made after the big earthquake. And another improvement in the operation practice is using the higher amount of insulation at the top of the kiln. And another is that we also recommend to use the shade and use the very dry green brick. That is the improvement in the practices. Beforehand, it was improvement in the only in the structures. Now it's the improvement in the practice. And also maintain the flue gas within the 80 to 120 degrees Celsius. That is also the improvement in the practice, the firing practice, which also gives us the maximum efficiency of the flue, the kiln. So if the temperature is above 120 degrees, the hot gas which can be used to dry out the green bricks in preheating zone, it is passed out. So if it is below 80 degree, then the tendency of getting accumulation of the water vapor inside it becomes high. So the most efficient design, most efficient operation is if the flue gas is maintained within 80 to 120 degree, then it is the most efficient design of the kiln, operation of the kiln. So we did that, and we just try to maintain this temperature within the firing. Another change that we did it in wicket gate, that is we say Dwari, it's the opening where we just take in the green brick or take out the fire brick. So huge quantity of loss is from here also, because it is open system. And during firing process, if it is the leakage, if it is not properly built, then the leakage from this part is very heavy. You can also see in the figure that if we have only 18-inch thick wall, which is the general practice in Nepal, is the amount of air leakage is 57% from that wall. Whereas if the improved kind of wicket gate we can in place with 5 feet of wall, then we can reduce in up to only 17% of air leakage from that wicket gate. That is one kind of improvement that we did. So what are the benefit of the improvement? The first benefit is the kiln structure of structurally safe and earthquake resistant design. Since this Nepal is very prone to the earthquake, so there is a tendency of big earthquake in the future also. And kiln itself is a very bulky, which has very bulky kind of huge chimney, huge walls, huge structure. So if it is not the earthquake safe, then still there are very huge risks of human casualties if it's same kind of earthquake happens in Nepal. So now improved design, we can say it's earthquake resistant. It is structurally safe. The chimney are safe, the walls are safe, the internal walls are safe, the systems are safe. As per the structural safety is quite high in the new design. And another is energy efficiency. Since we able to control lots of leakage, air leakage from this improved kiln, the efficiency of the kiln is quite high. We can experience that about 30 to 40% of fuel is saved because of this improved zigzag kiln. And another salient benefit is environmental performance. The environmental performance is quite good in the new improved design, which has about PM 2.5 emission reduction.
Apologies, I think Sanu also had another connection issue. I think he is trying to be reconnected. Let's give him a minute. So while we're waiting for Sanu, we mentioned that you're welcome to raise your questions. We will have a very brief Q&A session after these two speakers, after these two sector experts, so we can have some very fast interactions. I have seen some questions here, but we may not be able to cover all of this for now. So we're waiting for Sanu. We can go to the Q&A session, but I think Sanu finished the majority part of his presentation. He's already the second page to last on his slides. So maybe I would like to invite Mr. Liu Zhe. Are you ready to take questions? Yes, I'm here. So one of the questions come from the participant. It's on one of the ways of using kitchen waste is for the feed conversion, but you did not go to greater details. Would you mind to give us a greater a bit more introduction on what kind of waste are suitable for this feed conversion? And could it be deployed at small scale in the city with limited resources? For China's scale, it may be at our counties. Is it good to have feed conversion? Okay, thank you for the question. For the feed conversion of waste, this is not a very popular method, but I do believe this technology have great market potentials. So normally we would take kitchen waste as its raw material, so it is low cost and large in supply quantity, and they have a rich nutrition. There's a great profit margin, so this can be quite competitive. As we just said, it is a smaller scale facility. Normally, the capacity within 30 tons, so it will be used for the smaller scales. And for the conversion, there are two different ways. One is to add biobes for the fermentation, digestion, and remove these pathogens. The other way is high temperature treatment. So you will heat up to remove all the bacteria and crush to make it into a feed. There are mature feed conversion for kitchen waste in China. So we will have this crushing, drying, and other comprehensive technologies. And I think there are already several suppliers who are dedicated to these feed conversion technologies and come up with relevant facilities. There are several small-scale equipment available, so you can suit for the small-scale application in cities with limited resources. If you are interested for the feed conversion technology, we will have a speaker later from G-Screen, and I think this supplier may have more information for you. You can ask him the question. Okay, thank you very much, Mr. Liu. I think Sanu is back with us. Let's try to reconnect with him, see whether he can finish the last two slides.
I'm sorry, it's disconnected in my, there's a little problem with my connection system here. So let me share.
Yes, please.
Okay.
I guess you have one last slide to share.
Yeah, actually, I was at the end of the presentation, actually.
Yeah, please.
Okay, can you see?
Yes.
Okay. So I was talking about the benefit of the zigzag kiln. So the first benefit is the structurally safe and the earthquake resistant design itself, which is very important in the context of Nepal, where there are lots of earthquake going on. It's a very earthquake prone zone in the South Asia, Asian country. So another benefit is the energy efficiency itself. We have 30 to 40% of energy fuel saving in the improved design. Another salient improvement
Hi, Sanu. I think we are losing Sanu again. 我们的这个演讲嘉宾 Sanu 的网络不是
So apologies that Sanu do not have very good internet connection. Maybe we can have a quick break for now for 3 to 4 minutes. Let's come back at 2:40 in 3 minutes time, and then we will invite the suppliers, selected suppliers in urban waste management. We will have Mr. Zhang of Shanghai SUS. So please be ready, Mr. Zhang. We will start in 3 minutes, and let me reconnect with Sanu, because he also received some questions. Maybe he will come back for the Okay, that's the end of our brief break. And then come back to our agenda. We are more than honored to have with us Shanghai SUS Environment, Mr. Zheng, who is the head of the International Department. So he will share with us their great experience. There is a whole industrial chain comprehensive environment service provider. They have a great market share in China, more than 60 projects in 24 provinces and municipalities in China. They also have stable market share in Southeast Asia, Thailand, Sri Lanka, and other Southeast Asia countries. So please, let's move to the presentation of SUS Environment.
Can you hear me?
Yes.
Yes. Okay. Thank you. And very honored that we are invited to attend today's meeting, and we will share a little bit about our technology, our track records, and our development in the previous 10-15 years. First of all, a brief introduction to SUS and our development history. SUS is a pretty new company in this industry. We have around 15 years experience since we are started since 2008. When we started this company, we introduced the Hitachi Zosen's technology, the great technology, to Chinese market, and it became a manufacturer and the technology provider in the domestic market in China. And as we, the founding team in the SUS, we have been working a very long history in this industry in China. So we deeply understanding the market needs, the technology criteria, the trend, and coping with the technology from the overseas market. So we did a very good job to localization and optimization of technology to Chinese market. So since 2008, the starting up of this company, we did a quite great job in gaining the market, in the providing the technology and equipment. And still until now, SUS is still the largest waste to energy equipment provider in the domestic market. For the great equipment, we are accumulated. We have more than 40% of the total market share. After 2014, our company have one of the transitions, which becoming one of the major investor, developer, and operator of waste to energy projects in China. Because at that time we had a share transfer from a independent private company, become a state-owned company, controlled company. So after that, we become had the transition. As you can see from here, we are got the pretty much some symbolic projects in Chinese market from Zhuhai City, Ningbo City, and then spread out to across the nation. Now we have more than 60 BOT contracts projects across China, which the equivalent treatment capacity is around 100,000 tons per day, which is also equivalent to around 10% of the total market share. This is our major shareholders. Currently, we still have more than 50% of the shares are state-owned, which including Shanghai Industry, which is Shanghai government-owned company, and also Ningbo Chengtou and Zhejiang Energy. They are all the leaders in the urban development and also the renewable energy investment in the Yangtze River Delta. And we have 5 major business. One of the major thing is the eco-industrial park. This is something I want to put more emphasis on this part. The eco-industrial park is a kind of the comprehensive compound for treat different kinds of waste. And we can utilize the facilities inside of this eco park to make a circulation of the material and energy. And before that, before this concept has been introduced to China, we already have some very initial idea of eco parks. At that time, we just put different waste solutions facilities together in order to save the land, in order to ease the planning issues, the land limitations. But the second stage of the eco-industrial park is we put different of the facilities to utilize the energy and the materials one after another. For instance, in some of our facilities, like in Zhuhai or Ningbo facility, they have the kitchen waste treatment. They have the medical waste treatment as well. And in those eco-industrial parks, we utilize the heat from the waste to energy plant to dry the kitchen waste. And at the same time, the part of the residues from the kitchen waste will coming back to the waste to energy to the incinerator. So this will be an internal circle of the eco-industrial park. But this can be widely used, not only limited to kitchen waste or household waste, can also be utilizing treat of those organic waste, the sludge drying, the also the some of the industrial waste treatment as well. And this is our track record. You can see that it is being almost cover most of the part of the country for the projects which we have been invested so far. And because we are investing in eco-industrial parks, so besides this 100,000 tons capacity for waste to energy, we also have the capacity to treating the sludge, food waste, industrial waste, and medical waste as well. These are some of the typical projects we have been invested. Actually, because we are later comer in this industry in China, so most of the projects which we invested is within this 10 years. So most of the projects are pretty new. And in terms of scale, most of the projects are pretty large projects. We had a internal calculation that average capacity of our facilities we've been invested is around 1,600 tons per day. So which means most of the projects will be invested or operated are big projects. So big projects, I think, will be still not only on technology, on business models, on investment, they will have different conditions. But nowadays, we are starting also trying to doing some smaller projects within like between 500 tons to 1,000 tons, because I think in most of the developing countries, the scale of the per project would be around this scale, like 500 tons to 1,000 tons, as there are not many big cities in the other developing countries. But actually, we have most of the experience on huge projects. And this is one of the typical case which we have been invested in Ningbo City, close to Shanghai. And this is also a eco-industrial park. And for the waste to energy facility itself, it has several important points I need to raise. This is the very first facility in China which we introduced the ultra-low emission flue gas treatment process technology in the facilities, which is including SNCRs, SCR, wet method, GGH, and some of the traditional method in order to achieve a ultra-low flue gas emissions. And besides the technology of the flue gas treatment, we also has the very first facility in China, which is introducing the industrialization of the design of the architecture. So you can see from the picture that Ningbo facility is pretty beautiful, and it has some honeycomb concept in this facility. And of course, this is the first one which we are working with a French architecture firm, AIA, to develop this, to generate this idea. But the purpose, I think, is not only to make it beautiful. I think around 2016, 2014, the awareness of the environmental protection is more and more stronger in China. So we also have encountered the NIMBY not in my backyard phenomenon. So how to deal with this properly is the key to enhance or helping this industry to grow in China. So what we think is how we can make a facility or a industrial park is more eco-friendly and more adopted by the local community, and how to interact with local community. That is the key of everything which we started to design a firm. So not only on the technology side, on the architecture side, we're also doing some activities, the museums, the sports courts in the eco-industrial parks. All of the things we want to make these facilities an open area and welcome the communities, the people to coming into our facilities to understand what a waste solution treatment facility looks like. Because many people, before their understanding, they think it's dirty, it's pollution, it's harm to the health, and it's ugly. So we'd like to change the image of these facilities and the industry in order to enhance and collaborate with the communities to develop further projects. And these are some of the pictures inside of our facilities. I think it's nowadays, I think more and more facilities in this industry has become this kind of concept. But back like 7-8 years before, I think it's a pretty edging idea. From the technology side, I think Mr. Liu has just mentioned a lot of technology specifically. I think our later speaker will also focusing on the flue gas. So I will just a little bit explanation. That is a chart. We have the comparison of the Ningbo project, the emission, the actual emissions tested, comparing with our national standard and the EU 2010 directive, which means nowadays most of the modern projects we have done, not only SUS have done, I think most of the investors in China market have complied with at least the standard of EU 2010. And some of the projects came much lower than the EU 2010 directive. Another technology that is, for instance, in this facility, which is put into operation a year ago, is our facility close to Beijing. This is the very first project in China to introduce the high parameter and the reheating system into a waste energy project, which means we'll make these projects have a much higher thermal efficiency. And normally we know that most of the waste energy projects in China will have the efficiency around 23, 22, but this project has exceeded more than 30%. So it's a pretty good performance on the efficiency utilization. And this is our facilities in Nanchang in Jiangxi province. Besides the project we have been invested, I also want to add some of the points in our technology and engineering. As I have introduced that we're starting on the great technology and incineration lines. So we have put a large R&D team on the development of the technology for the combustion, the ACC system, and also the some of the related technologies to have the combustion more thoroughly and more efficiency. But besides, we also have developed some of the side technologies like the flue gas cleaning, the leachate treatment, and also the flash stabilization equipment and technology, and also the materials as well. We got some of the major progress and some prize we have got, and even some new technology, edging technologies are under development. This is our grade, which is pretty much the same as the Hitachi Zosen's technology, as we are the same source of the technology. These are the manufacturing base which we have in Jiangsu province and in Shanghai. And as I mentioned, that we are also still an independent equipment provider in the industry. So far we are supplying more than 246 facilities in China with around 500 incineration lines. And we have highlighted some of the typical projects in very different environmental conditions. I think because China is pretty big geographically, so like we have some projects in very northern areas like Harbin. They have very, very cold environment, natural environment. So how we do to do the protection of the temperature and keep warm of the facility to make it the waste is burnable is very the key of the technology. And on the opposite, we have a project in Sanya in Hainan Island. It's pretty humidity. It's a lot beside a seashore, so we have to face the high temperature and also humidity and the corrosion issues. And for instance, we have project in Lhasa in the high latitude, which I think is one of the highest the projects in the world, which is only have 2/3 of the normal oxygen content density, so which is also another challenge. So what we have done is we have supplied the projects to so many different different conditions, so make us a lot of track records and experience gained from those projects to how to deliver a technology to a very different environment. Add up the experience from Hitachi Zosen, we have delivered almost 1,000 projects across the world. These are some of the track records from Hitachi Zosen as well, and but also some of our SUS supply track record. Like we are involved in the very first project in Thailand, the Bangkok project, which is already being in operation for around 6 years. We've been delivered the projects in Sri Lanka, which was also the very first one in their country. Also, we have some other models, which like O&M, we operating and maintenance the projects for the other investors, because not all the investors are technology experienced, so they need some help. So this is another business we are involving. Yeah, these are some of our typical projects, which on the left side is our one of the projects we are operating right now. We are also the EPC contractor for this project, which is one of the largest one in China, in Hangzhou city, which is the scale, the capacity is around 5,200 tons per day. And for our international business, actually, we are rapidly penetrating to the overseas market, especially the Asian region. As I mentioned, we have been doing projects in Thailand and Sri Lanka, and we have been setting up some of the rep office across the Asian region. Actually, myself right now is in Bangkok, and we have office in Vietnam, in Malaysia, in Indonesia, in Bangladesh as well, and we will open more offices across this region. So we hope we can bring our expertise, our experience, and the capital into this market. The last but not least is a little bit introduction to our remediation business. This is the part which we are coping with our waste to energy facilities. Right now, we are operating some of the landfills, which is treating the bottom ash, the fly ash, and also we are doing the landfill remediation as well. But mostly in China, we got the very first project in Macau last year. Yeah, this is the brief introduction to of SUS, and I think it's precise 20 minutes. Thank you very much.
Thank you. Very good time control and very comprehensive introduction on the achievement that you have made. Eric, please know that there is also a question in the chat box for you. You are welcome to provide the response through chatting box, and you can also join the question and answer later after a few more presentations. Then we will move to the next speaker. 那我们就按照议程进入到下一位。
According to the agenda, we move to next speaker. From China Everbright. Let me double check. It's the speaker from Everbright, Mr. Zhang Hongbo, is with us now. Yes. Okay, I can see Mr. Zhang. Please share your screen while I give you a introduction. Everbright has great technology capacity and business support in urban waste management. They have more than 164 incineration facilities in China, and they also have existence in Vietnam and Poland, where they have international cooperation. They have leading technology R&D and design, and have several awards. So please, Mr. Zhang, start your presentation. 20 minutes, please.
Hello， 请问刚才我说的大家能听到吗？不知道是不是我的
You
网
can
络
hear me all right? Is it my internet connection issue?
We can hear you very.
So you can hear me. 张总监，请问您那个能听到我说话吗？
Can
您
you
能
hear me?
报告吗？
Can you share the slides?
那可能有一些网络。
So I think he had some connection issue. So maybe we can move over to the question to Eric, if you're still with us. Eric from SUS, please reply to the question while we wait for Mr. Zhang.
Provide your answer or response to the question from Mark.
Okay, you mean the questions, right? And I see one of the questions is regarding the smaller scale projects.
Yeah.
Actually, for the single incinerator, from the incinerator technology, we can do smaller ones. Technically, this is from our practice. We have done the smallest the equipment, I think, is like 7 tons per day. But the key issue for the incineration, I think, as I am a business background, I'm not technology background, I cannot explain too much about the technology. But from the business scope, the smaller projects, they have the issue is two key issues. One is the efficiency. When you invest in a waste-to-energy facilities, you always need to bear the cost on the OPEX and the CAPEX. But for the smaller projects, especially those projects smaller than 200 tons, they will have the problem of the energy efficiency, which means you will have very little energy can put onto the grid, even zero, which means the facility itself, they have the energy consumption, and your generation can only cover your own consumption, or even cannot cover your the consumption. They have a minimum. So whether those projects are economic, this is the very first thing we have to consider. And second thing is also, I think, is also from the business scope perspectives, is whether these projects are viable financially. I see some of those smaller projects, incineration, most of those incineration projects, smaller ones, are in Japan. But we know that those projects in this country, they can bear a pretty high tipping fees and the feed-in tariff. But this is something that I think is not viable in most of the countries at this moment. But I know that China, our ministry is starting to encourage the technology innovation on those smaller projects, as I think nowadays we have waste to energy facilities in China can treating like 1 million tons of waste per day, but that is only half of the total waste generated in the market, which means they still have like 1 million tons of waste waiting to be treated, properly treated. But now mostly goes to landfill. So our government is also encouraging the technology innovations on coping with those smaller facilities. Yeah. Thank you. I have answered your question.
Thank you, Eric. I think we still do not have Ms. Zhang from Guangda to join us right now, so we will just move to the next speaker. 那我们能否再确认一下那个华兴的
So let me double check. Mr. Zhou from Huaxin, are you with us? Mr. Zhou from Jiangsu, Huaxin? Yes, I'm here. Okay, great. Good afternoon. So you will be the next speaker. Brief introduction of Huaxin is the electric power environmental protection technology company. This is a leading technology supplier for flue gas purification. They account for 35% of market share, also their existence in India, Thailand, and Turkey. And Huaxin has the technology that can purify this flue gas and meet the EU standard. So Mr. Zhou is in charge of overseas business. So let me remind you about the language. We encourage the speakers to use either English or Chinese. So you can have the option of simultaneous interpretation. If you in English, you have more efficient coordination with our international audience. So Mr. Zhou, you can turn on your camera, unmute yourself, share the screen, and start your presentation. So, hello everyone. Hello, moderator. Can you see my slides? Yes, please start the presentation. 20 minutes. Okay, good afternoon, everyone. This is Zhou Feng from Huaxin. I'm a overseas sales responsible manager, and we are a professional service provider in flue gas cleaning. Our predecessor was founded in 1973. In 2015, we invited strategic investor and we set up specific emission control company dedicated to flue gas cleaning, FGC. And you can see here are our qualifications in Class B in air pollution prevention and control design, EP environment contracting grade 3, as well as import-export license. So here are our major product and technologies. Just like the moderator just said, we are specialized in the flue gas cleaning for incineration of waste. So you can see we have the following business areas of FGs, including DSOX, DDS, DNOx, low temperature flue gas conveying and stabilization, with technologies like the fixed spray process, circulating fluidized bag, rotary spray semi-dry, SNCR DNOx, SCR DNOx, including low temperature catalyst, wet calcium sodium alkali fly ash conveying stabilization process, and we have a complete service from designing, manufacturing to installation, commissioning, and after sale. In terms of technology, you can see we work with the leading brands internationally. We are the technology licensee of Nairo, of GEA, Mitsubishi, Heavy Industries, and we have in-depth cooperation in localized manufacturing, commissioning, and after service with Nero, SHAT, and Mitsubishi Heavy Industries. In terms of R&D innovation, we have a HXET pioneered the system layout under ERP management and application of BIM, building information monitoring in flue gas cleaning. So this is a basic set of equipment for flue gas cleaning. We have SNCR NOx and semi-dry SDA, plus dry process of lime injection and activated carbon injection, back filter, and fly ash conveying and stabilization. And that is Huaxing's core product that include the Rotary Automizer and low temperature catalyst. For the specific process, you can see on the slide, we have ammonia solution preparation, SNCR, lime slurry preparation, reaction tower for the semi-dry reaction, hydrolyzed lime rejection, activated carbon rejection, back filter, fly ash conveying and storage system. And for our performance, you can see we're among the top suppliers, and we are involved in more than 200 waste-to-energy plants in its FCG system, and we have built more than 400 sets of FCG systems. We have existence in 35 provinces and municipalities. And you can see on the list our clients, including the previous speaker, SUS Environment, Everbright, Grain, SE Environment, Shanghai Environment FML, Grand Blue, and Zhejiang Zheneng Environment. So these are the leading investors in renewable energies. So here you can see a simplified process flow for the streamlined flue gas cleaning. You can see the flue gas entered from the heat recovery furnace, and it will go to a rotary automizer, in which we will remove the SOx, the acidification with the reaction, and then it will go to the dust collector. Prior to that, we will have a spray dryer inspiration, including lime and calcium, that will remove mercury and dioxin and other toxic chemicals. After that, we can meet the emission standard of EU 2000 and China's national GB standard 2014. So here are a few product examples. On the left, it's a reaction tower in construction. You can see it is built on various modules. You can have the foundation with the steels, and then the crane will assemble various components in a modularized way. On the right-hand side, it is a finished reaction tower. This is the second product example, back filter for the semi-dry reaction. So this is the container, the outside shell, and inside this container there will be several bags that will act as filters. And the third product here is the Rotary Automizer. It can rotate at 12,000 RPM and can mix all this acid gas into flue gas in a very high efficient manner. So this is a 3D module for the Rotary Automizer. And this is our fourth product. We are just starting to use this low temperature catalyst. We talk about the NOx. They have SNCR and SBR. SNCR is to inject ammonia solution or urea into the furnace, and that is how you remove the nitrogen in there. But for low temperature catalyst, you will be able to remove the NOx without the ammonia with a low temperature catalyst.
This is a classical case. We have been involved with one of the largest projects, 2,000 tons per day. This is a project we are involved at Aituo, Zhejiang, a neighboring province of Shanghai. So we have been awarded at different levels. This is the national award on the project of flue gas undertaken by Huaxing in Linyi, in Sichuan, in Shanxi province. Many of our projects have won this high quality award we have. This was located in Taiyuan FGC WTE plant. That was in Yingzhou, Ningbo city. We also learned from the previous speaker about this project, China First. 3 multiply 750 tons per day. This is in Haining, not far from Ningbo, Zhejiang province, WTE plant. This is also Shandong, Huangdao. It has also won the national award. Last but not least is that we have a very good product processing equipment. We have 5 like plants. And also, for example, we have also the CNC flame cutting for fabrication, the punching, and also the laser cutting, as well as also the CNC 3D drilling. We are one of the players in China with a very leading capability on fabrication. So these are our presentation and then demonstration. Thank you for your attention. Yeah, thank you, Mr. Zhou. So you have shared with us quite sophisticated the technologies on WTE, especially for also the flue gas, waste gas, etc. If you guys have any questions, you may have interactions with our speaker at the chat bar. So there's another guy join us. So double check with you, Mr. Zhang Hongbo. Can you play the audio at least to share with us? You are from the Everbright.
喂，你好，不好意思，刚才突然掉线了。
I apologize.
我共享一个视频。
So I should have been able to share with you just now. Apologize. It's okay. The connection.
我来看一下我的。
I'm checking my deck.
OK， 可以看到吗
？Can you see my screen now? Yeah, you can start.
抱歉，好像又那个。
So it looks like you dropped again.
It seems that he always has the program of sharing screen. Let's wait for a second. Maybe I should do that for the speaker. 张总，请问您能听到吗？是不是要不我来帮你
？Hi, Zhang. I can share this screen with you. I can do that. Hi, can you hear me, Mr. Zhang? So connecting to audio. Connecting to audio. Mr. Zhang Hongbo. Yeah, hello. Yeah, I may share the screen for you. Can you do that?
好吧，我这边我不知道是出了什么问题，
然后
对，
我现在共享您看得到吗？就是然后每讲一张您就
So you please tell me next page.
好的，OK。行，那大家下午好，今天非常有幸在这里为大家做一个关于光大环境的节能减排相关产品和技术的一个介绍。
Environment on our product and the technologies.
请翻页。
Please next page, please. I'm already on this page. Can you see that?
不好意思，我这边没有看到。OK， 那行，那简单的介绍一下光大环境啊。光大环境呢是光大集团的下属企业，是专门从事这个实业的一个集团。那么我们1993年呢是在香港恒生上市，到2003年的时候呢转型环保业。到目前为止吧，经过10几年的努力，我们光大环境呢现在已经是成为了我们称之为叫做中国的环保行业的领军企业。
enterprises on environmental protection.
那么这里呢是我们的8大板块，也就是我们的主要业务。从左上开始，这是我们最大的一个行业，一个板块，就是环保能源。那么它的主业呢就是垃圾焚烧、垃圾焚烧发电以及相关的协同处理。在这个方面，我们已经做到了世界最大，也就是我们到目前为止有270个垃圾焚烧的这个项目。不好意思，前页没讲完。那每天的设计处理规模是已经达到了14.4万吨。不好意思，应该是前面。
144,000 tons. The previous page.
OK。第二个板块呢是绿色环保。那么绿色环保板块它的主业呢是做秸秆发电，还有呢微废处理，以及一些新能源的行业。第三个大的投资板块呢是水务板块。那么水务板块主业是做污水处理，包括市政污水。不好意思。
Hello, Mr. Interpreter. If I may interrupt. Could you check the setting of the interpretation function?
Yeah, the speaker's voice. The speaker may select the wrong channel. The speaker may select the wrong channel. The speaker select the wrong channel. Yeah, please double check.
Could you guide our speaker, please?
Yeah, the speaker need to select Mandarin channel. The speaker need to select the Mandarin channel. Mandarin Chinese channel.
Down. Can we proceed?
Can guide our speaker, please, to choose the Chinese channel?
You are right. Yeah, the speaker needs to choose Chinese channel.
张总，您看到那个您的这个 Zoom 的这个平台下。
So we are teaching Mr. Zhang to select the right channel. Previously, he selected the wrong channel. So now I selected the Mandarin channel, said the speaker, Mr. Zhang. Is it okay now? I think yes, it is okay.
Thank you very much.
谢谢。那
Okay, thank you very much. Do I need to repeat what I said? Do I need to repeat that? Double check with you guys. The speaker said, does he need to repeat? Yeah, you may go that quickly. You may go that quickly. So let's talk about environmental, the ever-bright environment. We went public in Hong Kong. We remains one of the largest player in this field. The largest one is about environmental protection and energy. We do the WTE, and also for the treatment, we have 270 projects. The daily scale of design has exceeded 144,000 tons. The second, we call it the green highlighted one at the middle upper part. The green are the eco-friendliness in hazardous treatment, remediation, including the photovoltaic, we call it new energy. And the third one is about hydro business. The main business is about wastewater treatment, also the purification. The fourth one is also highlighted in green on the left side, equipment manufacturing, especially for the incineration. We offered our core equipments. And also the fifth is about the resources. I know it covers the recycling, reuse, and the classification. Number 6 is also about our design and the planning. We have a planning institute, especially it offers the planning side some solutions, holistic solutions for urban management on different wastes, and also to offer the design to support the investment projects. Number 7 is our R&D, which is about scientific innovation on green technologies to backstop the environmental friendliness related sectors. Number 7 is our lighting business, Ever Bright Lighting. It targets the smart city, including also the street light lighting, and also for sightseeing, for energy saving like LED, put that together with the smart city. So all in all, we offer the one-stop solution, no matter for incineration, also to biomass, and also about hydro and wastewater sewage treatment. We covers from the investment, even as early as proposal design, the construction, tech support, including the O&M after the project is finished. Yeah, next page, please. The speaker said, next page, please. Looks like there's a connection gap. I have already turned the page to the page of Chinese map. Good. I still need to see because of the connection problem. Yeah, it's quite slow. Okay, said the speaker. Yeah, we need to introduce about our business. By the end of last year, we have reached out to 25 provinces and autonomous regions and SAR regions. We also reached out to even Poland, Germany, Vietnam, and Mauritius with our project presence. And totally, we have 528 projects on environmental protection. The total sum of investment reached 150 billion RMB. Okay, so for Everbright environment itself has been very well received by the different stakeholders, including the local governments. So this is the page of showing the award we have won across the globe. After 2014, we are listed onto the sustainability index of the Hang market. Starting from that year, we are also one of the emerging market index of sustainability global index of Dow Jones. So we have been very well received by the capital market as one of the leading enterprises on that. So next page, please. Okay, I'm gonna spend more time on demonstrating our core technologies. Thanks to the two factors that, number one, our main business is on incineration. Yeah, in terms of this business sector, accounts for nearly 70% out of our total investment and even the gains, revenues. I'm the tech advisor, especially the tech director on this field about incineration. I'm going to introduce more about that, including the following 5 technologies: efficient, advanced the incineration, ultra clean flue gas, the leachate water treatment, plasma melting, but also the solid waste synergy. Next page, please. So this is just for the sake of demonstration, a very conventional process schematic diagram, which may already been touched upon by the previous speakers. Starting from the right side, you have the unloading and also you pour it, and it will be used for fermentation in a closed environment, and also it will be catch. And from the groove, there will be a furnace at a very high temperature. The flue gas may be used by the boiler, and also for the steam generated will be used for power generation. When it may enter the following flue gas treatment system for purification. That's a very, very conventional process of incineration. And for that process, what are the challenges? The first is the thermal energy utilization rate is too low. The traditional incineration facilities, it is less than 22% for the thermal efficiency. What it can realize in terms of the parameter on environmental protection is not that good. It may reach the Euro 2010 standards, but when the standards have a trend of going more and more stringent, so it may be struggling to satisfy the requirement in the future. So we have core technologies related as follows. The first one is to improve the efficiency. So the overall methodology is that we want to raise the steam parameters of the boiler. If it is middle temperature, the pressure, the thermal efficiency is even just 22 or less than 22%. And also we did in 2013, 2015, we increased the pressure to middle temperature, but to have a sub-high or a sub-high pressure. So we reached the thermal efficiency of 25%, yeah, sub-high pressure. In 2017, we introduced the reheating system.
So with this new technology, we can further improve the efficiency to around 30%. With the improvement of the thermal efficiency, we have another challenge that the incinerator would have more obvious high temperature erosion. So we also have a targeted high temperature anti-corrosion technology. So after we have these innovations, we have a great economic benefit. From the slides you can see, if we have a capacity of 1,010, we have this medium temperature, medium to high, ultra high pressure reheat unit. It was a actual benefit of more than 50 million RMB per year. So with that, we can reduce the actual subsidy needed by the incinerators. So this new technology of reheat can improve the profit margin of the incinerators and reduce the relevant charge of waste management. And I think that is a good news for those relatively underdeveloped areas. And now we move to next slide. You can see there are two major stream technologies on the left for the flue gas emission. One is China standard, the other is EU standard. But there is need started from Chinese provinces like Zhejiang for utmost clean emission. Later, Zhejiang and Henan also have relevant local standards. And you can see they have a very demanding requirement for the particles as well as SOx and NOx. And that is why our conventional flue gas cleaning technology does not work. And that is why we developed this ultra clean technology, or it is almost zero emission. So after we go through the conventional flue gas cleaning, we have some extra devices. And with this low temperature SCR catalyst, we can greatly reduce the NOx. And with this wet reactor, we can also remove the acid gas in the flue gas. And with this combination of wet plus dry method, we can also control the particles very well. So we did a comparison with this ultra clean technology and still take a 1010 scale incinerator. Its heat value is 1,800 calories. And you can see, compared to conventional incinerators, emission reduction can be 7.6 of HCl per year, SOx 60.8 tons, NOx 228 tons per year. So you can see this is a great improvement for the emission. And the next technology is the leachate management. Next slide, please. So this is a self-developed technology. For the previous two ones, we did our own innovation, but on the basis of imported technologies. But this is a cell phone technology because we cannot find available good technologies in EU or US. They do not have the issue of leakage in incinerator because their waste is very dry. But when we build incinerators in China, we're faced with challenge of leachate. So starting from 2006, we start to develop this leachate technology. And up to now, it's already at generation 4. Actually, it's more than 4 generations. There is a 3.5 generation in between. We started from this pre-mix plus ammonia and UBF, SBR, MBR plus NF. And now we have pre-treatment IOC. It is an ironic treatment session. And then there is a complicated chemical and physical treatment And that is how we can better deal with the leachate and reuse the resources. And next slide, you can see the comparison of these 4 generations of technology. With the improvement of our technology, we have further reduced emission and have higher water recovery. Now at generation 4.0, now we can have 85% of that. And you can see the quality of the water had been improved, and we reduced the land coverage in a greater extent. And this slide shows our zero-emission whole recycling liquid treatment process. 85% of them can be reused in the cooling tower. For the concentrated solution, it will go to the area for the usage where they do not have very demanding water quality requirement. So you can see the leachate first go into the adjustment pool and go to the anaerobic tank. This is self-developed IOC tank. From that, it will go into the AO pound, and then it will be in the tank for softening. With specific chemicals, we can soften the irons, and then it will go into filtration, remove all these ions, and then it will go to RO, reverse osmosis, and then DTRO for the reconcentration, and eventually 85% of the water can be reused for the cooling. Next slide. And the next technology is plasma melting. We know that plasma is a kind of ionized charged gas, which is considered as a 4th state of matter, and it has conductivity. It exists at very high temperature, 3,000 to 5,000 degrees C, and then the gas will be ionized. With this technology, we aim to deal with 2 things. One is fly ash, the other is hazardous waste. The reason why we have the plasma technology for fly ash is that currently in China, the fly ash can go to landfill. According to the Chinese policy, but consider its sensitivity, because after all, this is a kind of hazardous waste. And all for this coupling technology, there is concern for its long-term stability. And for certain landfill, they have run out of the resources. So we hope we can have a technology that will deal with this fly ash and hazardous waste without occupying more land. So we have the similar consideration for plasma melting for hazardous waste. For the conventional way of dealing with hazardous waste, you will live with certain slags that will be landfilled as a hazardous waste. Is it possible for us to have a solution that solves the problem once and for all without further need of landfill? So we have this plasma technology with very high temperature environment. We can remove the hazardous component, including the hydrogens and dioxin. And with this high temperature, no matter it's flying ash or it's hazardous waste, it will be melted and cooled to be a kind of glass-like component, and all the heavy metal will be fixed in that. And after they were fixed, you would take it as a normal substance for landfill or be used as building materials, etc. So they have the advantage for this plasma technology because it is a very thorough solution, do not need to have a further landfill. And of course, they have its disadvantage that is quite costly. So if there's a specific need for the safety of this waste, and they have scarce land, then plasma may be a possible option. Next one is for the solid waste synergy. The reason why we have such a technology is for every city, as long as there need for dealing with household waste, there will be some other waste, including sludge, kitchen waste, and healthcare waste, etc. So in the old days, we also have various organic waste disposal facilities, but in the end, we found from the technology perspective, we found them pretty mature, yet they have limited capacity. The reason why is when you are building them independently, they have very high cost and they have single source of income. For the government, it would be a great fiscal burden. For smaller scale separated organic waste disposal facilities, for a long time, they exist in the organ state. The technology is available, but market is not yet ready. So starting from 2016, we have the idea that maybe there's a way to reduce the cost. And we see the reason why these technologies or these small-scale projects are costly. That is because they need energy, resources, including steam and electricity, and that is very costly, and that drives up its OPEX. Then naturally, we come to the solution that incinerators can be a cheap energy and resource supplier. We have residual heat and cheap electricity, and that can transfer into cheap steam. Is it possible to have incinerator as part of this synergy, and we can adopt other technologies deal with organic waste? And that is how we come up with the solid waste synergy. For this slide, you can see for the household, kitchen, sludge, and the healthcare waste, we did our calculations. So what we want to say is, if you build these facilities separately, you will see they are not sustainable economically, and that will mean heavy burden for the government. You need to pay a lot to have this waste disposed. Apologize. Please note your time. We have other speakers and you already have internet connection issues. So if we can have a synergy, then it will have a much better energy and it will be much better cost efficiently, and the government are more likely to pay. So we have incinerator as a core, and we can have other treatment plants. Then we can have a synergy in project design, construction, and operation. And there can also be unified planning. We can have a complementarity among various projects, and we can maximize economic benefit and energy utilization. So next two slides are the two diagrams. You can see it is a conventional industrial park model and our synergy park. For the old eco park, everyone deal with the issue by themselves. So each one of them will take a share of the land. There will be resource and energy flow, but they're relevantly independent to each other. But for a synergy eco-industrial park, you can see for the sludge, healthcare, and kitchen waste, they are built partially inside the incinerator, and that is saved in the construction cost. And for the previous mentioning the flow of energy and resources, we can realize the maximized use and further reduce its cost.
So this industrial park model will be of very good cost performance. So these are some photos, some classic projects we have, some of which are of bigger scale, some of which are of smaller scale or size, which means we can do a very standardized shop floor style, facility style. That's a very conventional and a classic style, but based on the property owner's requirement and local community's requirement, we can also build that into something aesthetically beautiful and which can be catering for the local community's requirement. And the last but not least is our unique projects actually in Changzhou City, in Jiangsu Province. Maybe it's the China only, the facility located at the very downtown of the city. It's a tier 3 city with supermarkets, with theme park, with neighborhood blocks. At the very beginning, we have no these above mentioned the community, and it turned into a very important part of the urban development as the downtown area, and it passed really the testing of such a newly built nearby community. We can see that for the incinerator, there's a park at the beginning, and also nearby we have also built our museum of the knowledge sharing. We built a library. We have city street garden as well. So many local citizens may have their like entertainment or other activities nearby. So a philosophy that we want to turn the incinerator a facilities for governance, not for secondary pollution or contamination, no matter from our technology's readiness or from our intention. We are capable of realizing that. Thank you for your time. Thank you for your attention. We really appreciate your great introduction about the case from Everbright Environment. So thanks to the technical problem, we are running behind schedule. So maybe we'll invite our audience to maybe raise questions. You can type the questions at the chat bar, and we will move on to the last representative, which is from also Beijing, Jielu. I'm very glad to invite Mr. Ju to share with us. And also in the field, especially of the organic the waste, the G Green has boasted a 2-decade experience with a lot of expertise on organic waste. Time is yours, Mr. Ju. Please manage your time. 20 minutes. 20 minutes. Can you guys hear me? Yeah. Yes. I'm also very glad to share with you about our technologies and about know-hows. And this is my agenda to go quickly. So we are a private enterprise established in 2004. We are awarded as also the high-tech enterprises in Zhongguancun, Beijing. We specialize in so-called a little agent, a little champion enterprises, especially in the field of kitchen waste and garbage leachate and municipal sludge, livestock and poultry waste, as well as the straw and other fields of organic waste are our specialties. We have nearly 2 decades experience. We offer customers with a set of the process design system integration as well as EPC management of the solution. We have covered 150 projects in more than 30 provinces and cities in China. Is our roadmap in the past 2 decades aligns very well with Chinese hypergrowth in the field of environmental protection. Starting from 2004, we didn't really have a clear-cut depiction. Most of these wastes were actually landfilled. We don't have a very successful models of incineration, so we have undertaken projects on the kitchen waste treatment, especially the garbage leachate. So anaerobic fermentation and anaerobic innovation, we have made big improvement progress. We covered all the business in Beijing and also expand our business to Guangdong. And also in terms of the technical know-how, and we also try to identify our specialty with legislation dynamics, and especially Chinese people start to pay more attention to the kitchen waste. And at around 2010, we have completed some large-scale the sewage treatment in the urban area, and also such a topic like the sludge has been very important. So we build our advantages. We know both the kitchen waste and sludge have really contained a very high level of the organic wastes, which is what we are good at. We started to diversify our exploration for especially kitchen waste treatment, sludge, the wet process, the livestock and the poultry manual treatment technologies are researched by us. We have accumulated the projects. And also at around the 2016, we call our industry witnessing more and more players. We call it a business model with 3 keywords started from P. And we work with the government arms in actually 5 provinces and cities. We have laid out 3 projects, BOOT. So the 5 different projects in the field on the kitchen waste treatment, livestock and poultry manual treatment. So 3 years ago. So we learned a lot about the classification about these garbages. So in China, it becomes so popular on garbage classification that nearly every neighborhood has been involved about waste sorting. We keep upgrading our projects. We introduced that the business scope covers from the residual liquid, leachate, sorting center, household waste. Our technologies reach out to both the sludge and organic fertilizer. Yeah, for kitchen waste, we built 1,000 tons in Guangzhou. That's the largest single project facility in China as well. Our business scope has reached out to the northern east, the southern China, middle China, and also Sichuan, and even reached out to Tibet. And we reached to like the Macau, very close to the southern China. We have reached 2,500 tons per day as the project on kitchen and kitchen waste. I'm going to demonstrate our technology and products. We have forged 5 key technical know-hows, including the integrated technologies on especially leachate, evaporation advanced oxidization technologies. And we also have the technologies as listed the kitchen food waste treatment, disposal integration, and multifunctional ones. Thanks to the time limitation, I have to go very quickly. The first about the leachate. So for leachate and biogas slurry discharge, for the pains in the industry is that it has complicated composition, very high organic matter and anomia nitrogen. Water quality and also the quantity maybe have some fluctuations, difficult to treatment. Concentrated solution produced by membrane treatment, difficult to be further treated. That's why we mentioned in terms of its core technology, CSTR, the anaerobic treatment. We work with Schumann, a German player, Mixel from France. These are international counterparts to optimize our design of the anaerobic tank and agitator. We have addressed the floating slurry, etc. And for the microbiological theory has been applied to the whole process of the anaerobic fermentation, increase its efficiency, improve the COD remove rate. Efficient COD is 8,000 mg per liter, and the large production of biogas 0.4 to 0.5 the cubic meters per kg. Our O&M has been very reliable. We reduce the time of debugging. Usually it's less than 30 days above the industrial average. The energy consumption can be lowered to 1.5 kilowatt per hour. Yeah, when we're talking about the treatment, about the regulating the tank, pre-treatment, anaerobic, the biochemical MBR, which is the master process. We have more stringent standards on emission. So you may need the membrane evaporation. It can satisfy most of the emission standards, but relatively speaking, for landfillers requirement, what we can do is as follows. We can use the main process, Fenton oxidization, the bath, the biofilter to reach the emission standards. For the second one, the Fenton oxidization to make sure the emission of the concentrated wastewater. The ever-brighten environment have laid similar the readiness and the presence on this topic as well. And also for the biogas liquid, and I also take reference from the leachate treatment process. It has already passed the anaerobic treatment of treatment, And we can have the following treatment process, including circulating water standards, incineration, plant coordination, pre-treatment plus MBR plus membrane advanced treatment technology to have concentrated liquid reduction or reduce the total amount. Now we have the pollution control standards for municipal solid waste landfills, pre-treatment plus MBR advanced oxidization plus biological aeration filter. And for Class A standards for sewage, we can also have the relevant system. This is the 3D model. So we have conditioning tank for pre-treatment, the anaerobic and biochemical MBR looks like this. This is for non-membrane ones, advanced oxidization, and also the biofilter, and also for sludge. And also this is the total treatment of the reverse, the osmosis concentrate for evaporation, MVR evaporation unit in the middle. Yeah, this technology is the mechanical evaporation rig compression, which is also boasted by G Green with our own IPRs, intellectual property. So for the efficient pre-treatment unit, we already have done a very important job, and we will have the desalination unit after that. So our efficiency of MBR is very high. The cleaning cycle of that has been extended from 7 days, which is the industry average, now to 6 days, 60 days, which is 2 months. And also the sludges can be used also for the landfill or reuse or incineration. That was in Shougang, that's Beijing Steel. 900 tons per day. I'll use the mesophilic, anaerobic, and MBR, NF plus RO. It was put in place 2013, awarded as the national level, the demonstration project on your energy consumption. And these are some other typical cases. On the left, on the right side is also in Beijing, Fengtai, 1,200 the cubic meter plus 250 concentrated liquid. You can see the ratio from concentrated liquid is 20 to 30% of the leachate. And we believe for anaerobic NF, RO, and combined with other technologies will also be on our radar for further improvement. And in field of the kitchen food waste treatment as further integration technologies is also a very important segment because it's from the requirement at our upstream supplier. So we started to tap into the followings. Yeah, number one, to understand, identify the pains of the industry. In 2019, I remember at the beginning of 2019, we have the classification, the standards. For example, for food waste is defined as follows: kitchen waste, household waste, as well as other food waste. So apart from kitchen waste, it covers the household wet markets waste
Recording
as well.
in progress.
Anything wrong? The speaker is asking. No, you can proceed. You can proceed. So for the co-chairs, please don't click the pause of recording. Maybe someone put the wrong button. Okay. It has covered some raw waste, right? But the pains of the sector are very similar. The first, technically, is not stable enough. For example, as introduced by the previous speakers, the pre-treatment process is about how to break it and also to filter, screen it, and compression. So the capacity is not enough, and the vehicle may have a very long queue, and effectiveness is not very working well. After rounds of physical treatment, especially for the pre-treatment, many organic matters, especially may be lost together with the inorganic one. So there's a large amount of residue, moisture content is very high. It cannot satisfy the disposal requirement. We have to, for example, dry it before further landfill or incineration. Yeah, thanks to the loss of organic matters, the extraction rate is very low, and the yield of the marsh was very low. The serious oil loss, it is not economical. And also for the food waste on the right side, it's just after you maybe you learn from the kitchen waste treatment. So there are many references we can take. Some of the pains, open questions on food waste pop up again. So for these kind of pains in the industry, we propose our own design concept. And for the kitchen waste, these are as follows: starting from the pulping and then separation. For the pulping equipment, as shown here, we take some reference from the pulp, the paper pulp, and with secondary development, and we have the receiving hopper, the hydrocyclone pulping, screw extrusion, and a collection of the broken bed, rubbing, washing, separation.
So you can understand it is something similar to a washing machine. So we can separate the organic matters to better extract these matters for anaerobic fermentation. So this is our module. You can see there's a receiving unit. It goes to hydrocycle pumping unit, and then three-phase oil extraction to remove the oil and the slurry, and then the high concentration organic solution will go into the anaerobic unit. For the biogas slurry treatment, similar to the leachate treatment as I previously described. So this is a hydroclone pumping unit. It can be flexible in its scale. It can deal with 5 to 60 tons per hour. The extraction rate of organic matter can be higher than 80%. Residual rate is less than 20%, and the chronic value is around 1200 kcal. This is a three-phase oil extraction, so it can have the sand removal, heating, and surface separation, and the efficiency of oil separation can be 97%. Here list the other supporting equipment: high pressure extruder to remove the moisture, and slug remover to ensure the size of the feed material is uniform. After redesign this kitchen waste technology, we can shorten the process chain by 50% and the queuing time by 70%. There's high purity in slurry and few inert substance, so biogas output can be 80 to 90 cubic meters per ton of waste and less than 10% of the residue. The moisture content is less than 65%. The oil per ton extraction had been improved by 2%. So you can see this is a trial in Beijing Nangong. You can see our capacity is 380 tons per day. It used to be 380 tons per day. After our optimization, the residue is now less than 22%, and the oil extraction is 4.5%. You know, the average oil extraction rate in the industry is around 2%. So that's almost 100% improvement. So with this technology, we can have a in-depth analysis and come up with design concept. We need to change the raw material into mature material, so it should be ripened before pumping. So it's like a thermal hydrolysis with high temperature and pressure, and then with hydroclone pumping, we can have constant concentration of organic matter. So this is our process. Starting from receiving the feed, it will go to the thermal hydrolysis to extract the organic matters, and then it will go to the pumping after the thermal hydrolysis to remove the oil and the impurities, and then the rest go into the biogas unit, and there will be other purification and deorder units. So this is our independent technology with patent. This one is for thermal hydrolysis. With the 100 to 150 degrees of steam, there can be rapid ripening. It's quite similar to kitchen waste. With the thermal hydrolysis, we can have greater adaptability to the waste, and we're not picky with the raw material. As you can see from the previous ones, we do not need complicated pre-treatment, and we can have stable operation. We can shorten the process chain by 1/3, and the much less residual content, less than 20%. And there is a high extraction rate of organic matter and the yield of biogas. With this thermal hydrolysis technology, we can very effectively remove all the organic matter. We break the cell walls, and they can have a great advantage of the recycling. So we have this technology adapted to slurry and sewage. We have greater advantage. With the limit of time, I will not go to its details. So we have another concept called thermal hydrolysis plus. So it can be used widely for organic waste, for food and kitchen waste, and slurry, as well as for the animal dungs or animal waste. So with different scale and investment, you can have different options. You can see for thermal hydrolysis, for generation 1.0, there is thermal hydrolysis plus extrusion. The project is in Likang. For the generation 2.0, we have thermal hydrolysis plus hydrocyclone pumping plus extrusion. So the project have Chuzhou 300 tons per day and Zhengzhou 150 tons per day. While China have greater favor policy for the waste classification, we are embraced with a great background, and we are interested in the sorting technology, which can contribute more to society. So we come up with this 5-in-1 sorting center proposal. So you can see, you can have the hazardous waste, kitchen waste, household waste, etc. So we can sort this in a high efficient way. There's much less ratio of hazardous waste, so we can build in the same module as recyclable waste. For kitchen waste, we can have our mainstream technology, pre-treatment plus anaerobic digestion. For large pieces of garbage, we can have crushing plus magnetic separation plus packing. For the recyclable, we can have sorting, packing plus recycling. Other than this waste disposal and sorting, we also have intelligent classification monitoring platform. With the assistance of big data, we can better manage the collection, transportation, and supervisors. We also have the education center integrate popular science education and interactive experience. This is a 5-in-1 sorting center, and it can be very good for the local government to popularize its waste classification. In Zhengzhou, we can have such a center account for 9 mu with a capacity of 150 tons of food waste, 10 tons of large piece, harmful hazardous waste temporary storage 2 tons per day. This is another design for Changping County government. You can see we have the large piece sorting, the kitchen and recycle waste disposal, anaerobic zones, biogas utilization, and promotion platform and office area. So you can see the design looks like a garden instead of a waste treatment center. We're also very enthusiastic in the innovative technologies. We know 2022 is the beginning year for China to promote rural revitalization and carbon neutralization. China is a large producer of agricultural waste, and it can also be transferred into high quality resources. So for the dealing of the straws, there is a national policy of no incineration. We prefer you transfer it to feed or base material. It can also be composting or waste to energy, and it can also be used for the raw material of paper making. So it can be used in the pulping industry to replace the deforestation. So we can come up with this technology that part of the straws can be used in anaerobic digestion. So biogas can be used in the rural area, and we can also have engines to make bio pulp making. so it can have extra income for the local farmers. And for the biogas residues, as well as the slurries, it can be composting and used as organic fertilizers for the smallholder farmers. So this is a comprehensive use of the straws. The waste can be now transferred to resources and energy, and we can have extra energy and extra income. For China's, please note your time. With China's carbon targets, we have this notion of organic waste factory. This is our concept to reduce the pollution and the carbon emission, have energy self-efficiency, and be environmental friendly. We can collect the solid waste from both urban and rural areas, and they can be transformed into fertilizers, pumps, and energies, and they will feed back to the cities and rural areas. And this is a comprehensive way of using the solid waste. So I think it is similar to the synergy concept of Everbright, and we did our exploration. So for the future factory or plant, it will be dealing with organic waste, but also a generator of green and clean energy. It can produce organic fertilizers. And here I list all the awards we have received. For future corporation development, we were founded as EPC key handling model, and then we have EPC plus operate, public-private partnership, BOT and BOO, and other models. Right now, some of the projects have already been operating for 30 years. We find there are certain areas that we can improve. So we also have this ROT model, this reconstruction, operate, transfer, as well as EMC and CES. This is new way of business model, so we can co-create value. So here are some of our partners. You can see enterprises, including SOEs and foreign companies, and hope our technology can go overseas to empower more cities. This is our mission, realize the natural cycle of urban rural organic waste with high quality by industrial method. That's all from me. Thank you. Thank you very much, Ms. Xu. That's a very detailed introduction of your technology, and you have various cooperation models for potential partners. If you have any questions for her presentation, you can raise it up in the chat bar, and we will have a Q&A session after the last speaker. Okay, without further ado, I'd like to invite our next speaker, who will give us a technology introduction of Break Kilns. Mr. Song Chao comes from Beijing Qinhan Project Management Company, who is also an engineer in China Construction Material Industrial Planning and Designing Institute. It is the only comprehensive service provider from that arena. And they are highly comprehensive and they have strong R&D capacity. They can provide consulting service to many construction material companies. They have more than 5,000 projects in China and 200 overseas. And they are highly recommended by our partners in other Asian countries. So please, Mr. Song, can you share your screen?
稍等一下。现在你能看到吗？
可以，请您用全屏，然后请您注意时间，您有20分钟。
Manage your time. So please finish it in 20 minutes. Thank you.
现在已经看到 PPT 了，对吗？
We can see your deck. Yeah, we can see that.
Hello everyone. This is Song Chao, come from China Development Strategy Institute, Building Material Industry. as Vice President and Senior Engineer. I'm also the Managing Director of Beijing Qinghan Project Management Company. Today, my topic is about the Asian brick making sector with clean air and energy saving. When I traveled in Asian different countries, the most frequent question asked by decision makers of governors or bankers or the entrepreneurs, it is what kind of building material shall we use in our country for energy saving? Basically, we have three types of mainstreams building materials as cement bricks, red bricks, and air-added bricks. So I tell them that you have to compare the index as I list here for conductivity of the thermal index and also the specific heat capacity of this index I list here. For the conductivity, is something that we, when we talk about the building material, we do not want to exchange the temperature no matter you are in the hot weather region like India or Sri Lanka or Malaysia, or you are living in some cold places like Mongolia. We don't want to exchange the heat or temperature inside and outside. There's a case happened in 2015 in Iraq. Previously, red bricks are frequently used in Iraq as a traditional building materials. But in 2015, they choose cement bricks as a new type of building material for them. You know, Iraq actually is a very hot place. If you want to travel to Iraq, I have one small tip for you. When you open the water tap, you try to make the water tap open for 1 minute. Otherwise, the hot water will burn your skin, which I want to say actually Iraq is a very hot place. But in 2015, with the Iraqi rebuild program, they gave a lot of cement factories to give the building materials, which have a very bad insulation. In 2017, with the investigation, as I showed on the left part of the screen, investigation of the building material issue in North Iraq for residential projects, they have a report and there are so many problems for the cement bricks. The main problem actually happened that cement bricks are not suitable for the thermal insulation of Iraq of the extreme hot weather. Or we can say for our Asian countries, cement bricks are also not that suitable for extreme hot or cold weather. If you can see the picture here, as I draw here for the red bricks from morning 4 o'clock to evening 18 o'clock with the sunrise to sunset. We really need a very good insulation of the building material. If you can see this curve with the red color, it represents the red bricks, while the blue curve represents the cement bricks. The peak temperature for the cement bricks is around 45 degrees C, which will be reached at 12 o'clock in the noon. With the red bricks build up, you may say the peak temperature are delayed and reduced only 33 to 34 degrees. Another index we want to discuss for the Asian building material is about the density. The latter building material, it is the easier for us to make the high building and faster building. Even a little worker can carry this AEC for its construction. Actually, AEC is a winner for this index. So comes the question: why the Iraqi gentlemen in 2015 they tend to cement bricks for help at that time? Because the cement bricks are really cheap in terms of initial investment and investment based on same capacity. You may see the AAC and the red bricks technology almost 10 times than the cement bricks. Raw material. When we discuss about the building material, you have to say we consume a lot of raw materials for making them. So for AAC and cement bricks, we have a C in the English. The C actually represents cement. To be honest, exclude China, Asian countries have some issue for the cement production. Number one, the price is almost double than in China. And secondly, the cement as a raw material is too expensive and too heavy polluted. When we discuss about the pollution for making building materials, we cannot only compare itself, we also have to compare based on the principle of all life cycle or all process cycle. So if you are using the cement to make a brick, you also have to consider the pollution and the energy consumption when you are making the cement. Here's one case come from India from 2013 and 2015. When I traveled there, the new trend for making the building materials to set up the AAC technology. But since the cement bricks price, since you have to use the cement to make the AAC, the cement price is almost double than in China. So the AAC manufacturers, they try to reduce the cement, and the quality is really very bad. So the Mumbai government, they decide to give a ban to control the production of AAC. This is some design we gave at that time for them. But on the other hand, the raw material for the red bricks are very red. I give 4 pictures here. You can say from the Bangla clay, the India weathering shell, the Algeria soft shell, and China kogan. Also, there's one kind of raw material for red bricks is called dredging sand. This kind of sand, every year we take it out from the river. We're using this type of boat to take it out. It is sand, but the particle of this type of sand is too fine. You cannot use it for other building materials. Only the red bricks can use this one to make the red bricks. And if you don't do any cover for this in the windy day, with the wind, it will blow everywhere. And every year you have to redo this job again and again. And even nowadays in China, the government encourages us to use more water treatment plant waste, as so many speakers today introduced. They are more professional for this type of topic. For the moisture control, for the red bricks, we can understand they have a lot of, we can see in the red bricks, we can see the red bricks under the microscope. You can see a lot of particles. These particles could dissolve the water. We feel very comfortable as you are living near to the lake in the red bricks. When the weather is too dry, the water will be released from the red bricks. And when the weather is too moisture, the water will be stored. So we may have a conclusion for this part. For all over Asian countries, what shall be the best building material? Red bricks seems the winner, is most successful building material over Asia. So based on this conclusion, since 2011 to now, with the ADB support, we try to help 100 projects using the clean type for FCK, HHK, and tunnel clean. And here's some and machinery. And also we try to give some management help to the developing countries, since they have some issue for management. the second sector. For the second sector, I'd like to discuss about something about red bricks and its challenge. If we want to develop the red bricks, of course, we have some issue here. In our Asia, we follow this history of the kiln in development. The first generation of kiln required shuttle kiln, and then it developed to zigzag, and then to FCK and HHK, and then tunnel kiln, which are admitted by China, Europe as the most advanced technology. Again, I want to compare several things for zigzag, FCK, HHK, and tunnel kiln over Asia. The first thing always come to our mind is about the energy, efficiency. So one day, when 5 years ago, one gentleman, he come to me. He's the owner of the zigzag. He come to me. He say, Frank, hey, how much coal consumption for one tunnel kiln for 100,000 pieces per day with 5,500 kilocalorie per kg coal? How much? You always tell me that tunnel kiln is the best technology, which is the most energy saving technology. So how much do you consume for the coal per day? I tell him that the answer is 13 tons. And then he say, oh, so that's weird, Frank. You know, my zigzag only consume 11 tons. Why your advanced technology even consume more energy than my one? Basically, the answer is that the maximum temperature between zigzag, FCK, and HHK and tunnel kiln are different. The maximum temperature for zigzag is around 600 degrees centigrade, while FCK 600 as well, HHK 900, and tunnel kiln 1,100. Basically, in China, we call zigzag and FCK, those bricks, they made underburnt or unburnt. So in the market, you can easily say, for example, in Iraq, now you can spend 120 local currency to buy one piece of brick from zigzag or FCK, while you have to spend 240 for one piece of brick for coming from the tunnel kiln. In our neighbor Bangladesh, you have to spend 15 Dhaka to buy one piece of brick come from tunnel kiln, while only 6 Dhaka to buy one brick from HHK. Here's a curve for the tunnel kiln technology, which can reach 1,100 degrees centigrade, which we make the bricks fully burned. And sometimes for, here's a chart. Here's a chart for the chemical composition of the raw material. Sometimes when we try to burn the red bricks, the silicon oxide and the aluminum oxide is high. If it is high, you need a higher temperature to burn it. Basically, tunnel kiln is the only option for this type of technology. Just 1 year ago, the China CCCC come to me and they say they want to buy some bricks in Bangladesh. They want to test different suppliers' bricks. This is a machine that time when we are using this type of machine to test the strength from of the bricks from zigzag, FCK, HHK, and tunnel kiln. And on the right side, you may say the bearing the pressure. The bricks come from zigzag and FCK only 2 to 8 MPa, million Pascal. So we turn to 20 to 30 suppliers at that time, but only the tunnel kiln company gets this order at last, because CCCC they give a standard, say at least I need a 10 MPa as a building standard. Not even to say there's another index which called the frozen soil resist coefficient, 抗冻溶系数. This is useful for Mongolia and other cold countries in Asia. But to be honest, the FCK or zigzag bricks is okay for this type of index because we really not suffering from the coldness in countries like Nepal or or Bangladesh or India. Basically, I'm not a stereotype for any type of technology like HHK or tunnel kiln or Hoffman kiln. I embrace all the technology myself. Even I developed this zigzag for Middle East. Just a half year ago, this is one kind of new type of zigzag, which have installation materials on the ceiling, which can give more than 1000 degrees within this zigzag. This is a layout for it. Second thing we want to discuss in the sector 2 is about the fuel. The challenge come from the fuel. Yesterday, I listened to Mr. Suesh presentation. Is very good. He has some idea. I totally agree. For example, nowadays when we try to use a coal or CNG, LNG, biomass for brick sectors, we really have a lot of challenge. For example, for the coal, for some countries in Asia, you don't have the coal yourself. You have to import from India or Indonesia. And you have to save the energy, you have to save the cost, running cost for the brick factories. The coal price is hiking all the time in the past 5 years. Now it's almost a double. And the CNG, LNG price sometimes is also not that cheap. Then people try to develop the biomass. Biomass, we can say is rice husk or some other biomass items. The energy contains within the biomass is around half of the coal. But here's the problem. You have to say the building material industry, or you may say red brick industry, is not a high value added industry as other industry. All this type of fuel, we are the last industry to use it. Like the mother always shouted at us, it is not your turn to use a good fuel. For example, previously we developed this type of we developed this in the north part of India and Bangladesh for the fuel bar machine. And then the manufacturer of these fuel bars, they say, oh, I can get more money from other industry. Why I shall give these fuel bars to burn the bricks? And also especially for the South Asian countries, actually they have very high moisture of the rice husk and other biomass fuel materials, which means you have to use energy to dry the water itself, and then you can get energy. Sometimes it's just not worthy. And the third part for this, I really want to share something about my understanding about the brick standard. Actually, as a Chinese culture, sometimes we are too humble and too shy to share our standard to our neighbors. I strongly suggest that China promote its brick size and standard all over Asia, because China actually have different weathers, hot and cold, and we have done many tests for the bricks from the most hot weather, say Guangzhou city, to the most cold part, say the Heilongjiang province. China bricks now are very reasonable in size and design nowadays. This is one type of brick size for British bricks, which are the mainstream in India, in Nepal, and Sri Lanka. It's 33 millimeters thickness and 253 torr. When you burn this type of bricks, you have to use 40% energy more than the slim bricks like the China standard. As yesterday, Mr. Suesh also shared a very interesting cases that the Nepal people, they don't want to give the hose like this one to they don't want to buy this type of bricks, because they think that if the bricks have the hose, the strength will be influenced. But if you make the solid bricks in this way, too much energy are wasted.
提醒您还有1分钟。
1 minute reminder. I'm almost finished.
These are some pictures we made for the Chinese industries and also the layout. Here are some certificates of our design house and the company. Here's my contact number, and if you are speaking Arabic, you also can contact our Arabic colleague, Mr. Abdullasif, and if you are speaking Russian, also you can contact Mr. Alina, our Russian colleague. Thank you very much.
Thank you, Frank. You have a very informative presentation to show how BRICS can help the energy saving and emission control in more countries. 非常感谢那个宋超先生。
So I'd like to thank you very much, Mr. Song, for being the last but not the least speaker. It's a splendid presentation. Because we had some technical issues, so we were not controlling the time as perfect as I wanted. Well, I want to share with you some of the housekeeping announcements. At 5 o'clock, we need to go back to session 1 precisely for the closing plenary. And we do have some time left. You can consider to have a view of our chat area. Some of the question has already been answered there. For the other questions, we can invite our suppliers and experts stay with us. And for other participants, if you are interested, you're welcome to go to our website, www.cleanairasialive.com. So you can have a view of other great technologies, and you can download relevant materials, and you can contact us, or you can contact them directly for future exchanges. We also invited you to have a questionnaire prior to the meeting, and then you can follow a link shared by my colleague Dan for a questionnaire after this session. So this is our last minute for Q&A. I wonder whether the speakers are available now. I'd like to first of all give the opportunity to the participating countries. I noted down several questions. One of them comes from Mongolia.
The participant mentioned that he or she was very interested in setting up a waste-to-energy or eco-park, which was mentioned in one of the slides. Usually small to medium-sized type like in Mongolia. So what would be the average period for covering such investment? And does your company has such kind of capacity and has been involved in such kind of projects abroad? Please share. Thank you.
Okay. Thank you for the question. Actually, as I have answered one of the questions earlier today, is regarding smaller scale projects. From our perspective, smaller projects, technical feasible, but financially it's very difficult. It's not difficult. It's lots of challenge, which means that you require a higher tipping fee normally, and of course a feed-in tariff. But normally smaller projects, you will have very limited energy output, so the feed-in tariff would not contribute a lot to your cash flow. So the key would be on the tipping fees. Answer your question on the coverage of the payback period. That is what I think your question is related. Normally, there is a very important idea or concept is we have to figure out how we develop a project. Mostly before China become the largest single market for waste to energy, before that, most of the waste to energy projects are located in Japan, in Europe. And in these particular markets, they are very different market comparing to the developing countries. Like in Japan, most of the projects is government dominated. They are developed projects, invested projects. And in Europe, many of the projects are based on commercial development and other countries, commercial contracts, because they've already set up a very mature system for the payment system, which means the end users have to pay for a higher treatment fee of their waste. But this kind of concept and system is not very much mature or established in developing countries. So China deployed a very different way to develop this industry, is the PPP model. Most of the projects in China are under PPP scheme. So under the PPP scheme, they will have a financial feasibility study initiated not only by the investors, the private sectors, but also from the public side as well, which means the government will have, normally is the Ministry of Finance, they will have the evaluation of the payback period of those projects, whether your CapEx, OpEx is reasonable. So normally, if we take the figures in China, we have seen that most of the PPP projects, including waste to energy, had a very limited range of the return, which means normally in China, currently most of the PPP projects, we have 8 to 10% of the internal rate of return, the equity part. So which is equivalent to around 10 years payback period. If this project is like a 20 years concession period, the payback period will be around 10 years. So this is from the figure side. And I want to also answer one of the questions I noticed in the chat box earlier is regarding the carbon neutralization, which is also a very hot topic right now in the market, whether waste to energy projects can have any additional income from sales of those carbon emission deduction or CCER side. China has already starting to setting up the CCER market. And from the waste to energy in China, yes, it will. I think it will be counted as a solutions to helping in the CO2 emission reduction. And we know that normally comparing to the conventional landfill or comparing to those coal-fueled energy projects, you have a tremendous emission reductions. And we see that especially comparing to landfill, that we will see a reduction of the carbon emission is around the 0.7 tons per ton of waste. But I think in different countries, when they're setting up the CCER market, they will have very different calculation criteria. And even in Europe, I heard that they will not include waste to energy as incineration into the CCER system. So it's a very different based on which market you are at. Yeah, thank you.
Thank you, Eric. Very informative response to the question. May I check that if Sanu is still online? I tried to chat Sanu because there are a few more questions for Sanu. I think Sanu may still have the challenges of connection. So let me ask the question to maybe Sanu. Okay.
Yes.
Yeah.
Yes, I'm here.
Sanu, did you notice the chat box, the questions for you? There are a few more questions, but I don't think we have all the time to cover all the questions. Do you want to add some response to address the concern? To address the question. Maybe I can also repeat.
Okay, actually, I have one more last presentation
Okay, please.
Can you repeat the question, please?
Okay. The question is about, can you suggest the best low cost or zero cost steps that could be taken to secure some quick air quality best benefits from controlling the emission from brick kilns? Maybe this is a general question that many participants have interest to know. And I can also help you to finish the last slide if you want. I help you to share the screen. Okay, then.
Okay, actually, my last slide is the answer of the question itself.
Okay, I will share.
So I will just quickly share my last slide. Okay.
Okay.
Okay, I will share the last slide.
Okay, please.
So I was talking about the benefits of improved zigzag kiln, and I think I have covered all the benefits except the brick quality. Actually, with the improved zigzag kiln, the brick quality, we have experienced that about 90% of the bricks are about 90% of brick are A class. That here in Nepal we have the grading system: A class, B class, and C class. And A class is the best brick quality, which is more expensive than another bricks. So we could get more than 90% of A class brick from improved zigzag kiln. That is my last benefit. So regarding the questions, so if you see the last slide here, we can see what is the main conversion cost. I was talking about the fixed chimney zigzag kiln. So initial investment to build the new improved zigzag kiln is about 100,000 USD for the establishment of new kiln. Whereas for the conversion, if some entrepreneur he has the fixed chimney BTK, FCBTK, and he wants to convert from his kiln to the improved kiln, one day he can just spend about 20,000 USD, and he can get the new improved kind of kiln. So I think the most cost effective and cost efficient technology conversion kiln. So existing condition, he has the walls here. He can just improve the wall thickness. He can just cut the edge of the kiln and improve to convert into zigzag kiln. And also he can just use the same chimney with some improvement in the chimney itself, and he can just add the fan, different things. So only adding about 20 to 25,000 USD can convert his FCBTK to improve zigzag kiln. So to build a new one, it costs about 140,000 USD in context of Nepal, whereas to only the improvement, it's very cost efficient. So in my opinion, the most cost efficient and cost effective technology to bring to convert in energy efficient way in a low cost is the just to convert FCBTK to improve zigzag kiln. But if we talk about tunnel kiln and Hoffman kiln, I agree that it's more energy, it's more efficient in terms of emission and more worker friendly, and we have lots of benefit with the tunnel kiln and hybrid Hoffman kiln, and very low cost and effective. Then in my opinion, it's the improved zigzag kiln is very cost effective, which compares with the existing FCBTK and the improved zigzag kiln, which has benefit of saving up to 30 to 40% of fuel, and also it has emission. We measured the emission of compare the emissions from FCBTK as well as from improved zigzag kiln. We can cut down about 20-25% of PM 2.5 SPMs, and as well as black carbon is also reduced. So I also put the link of the research that conducted by Isimod in Nepal. So it's in chat box. You can also go through it. So that is my last slide. And yeah, thank you. That's my last slide, giving me time to complete my presentation. Any other question?
Thank you, Sanu. A very perfect end for this breakout session. I think we covered all the presentations, and we also have very active discussion through chatting in the chat room. Very good slide. Very good presentations. Yes. Thank you, Sanu. Because we only have 10 minutes left, so I have to end the breakout session now. Please stay to fill out the post survey that my colleague shared, the link in the chat box. And please also feel free to explore the meeting website to find further information on more technologies and of other companies, and of course also the technology information and contact details of the companies that already shared this afternoon. And I would like to thank you all the presenters, and also thank you all of the participants that you stay with us for such a long afternoon after a lot of presentation and discussion. 好的，那今天这个部分的这个
So we're gonna call it the end of the third branch session. So have to call it the end. Thank you very much. And I just repeat what she said in English. Yeah. Let's keep in touch. Learn more from our website. You may contact them, or you may contact us. Yeah. So we have the case study, and we have a technical menu. We'll try to collect as much as we can share, like we have demonstrated today. Thank you.
So I also wanted to thank everyone. So I have just launched the post-meeting evaluation, so that this will definitely help us to tailor and improve the succeeding trainings and knowledge sharing activities that we will be organizing for the project. So we appreciate your feedback. It's only 8 questions, and we will compile all of the results across the platform, so that this would be the basis of our targeted trainings that we will be organizing for the TA6. So again, I'd like to invite everyone to visit our technology platform. The link is in the chat. And after that, at 5 p.m., we would like to invite you to join us in Breakout Room 1 for the closing ceremony. So, thank you. I think we can give them time, like 1 minute more, and
yes,
then we can all move to the technology fair and the breakout room 1.
Yes， 请不要点结束问卷，只有那个组
Please
织。
don't click end or close the questionnaire or survey. Please don't click that by yourself.
Recording stopped.
So 30 seconds more. So those who have not yet filled out the poll, we invite everyone to do so. I'd like again to, of course, acknowledge the participation of our partners. I can see still participants from the Philippines, from Bangladesh, from Kyrgyzstan, Mongolia, Vietnam, also Pakistan, Japan, and Thailand. So thank you very much all for staying up to the end of the program. All right. So thank you. I think we have some 10 seconds more. So please don't forget to click the links in the chat box, and we hope to see you all later in the in the breakout room 1 for the closing. So over to you, Wei. Thank you so much.
Thank you, Dan. 请大家稍事休息和浏览我们的网站之后，
Thank you very much. Please be back at the breakout session 1. Be back at breakout session 1. Just to reiterate, don't forget to get back to breakout session 1. Thank you very much. We have left also the linkage at the chat box. So we will start like only in 4 minutes. See you. I want to end our breakout session 3. Thank you all. Bye-bye.